Prasad sir, they both have
Good
joined.
afternoon, sir. Very good afternoon, sir.
Prasad, good afternoon.
Good afternoon, sir. I'm making a note, sir, whatever is going on.
Yeah. And you are the director of the Amity Institute of Space Science and Technology and an expert in the field. So you will have to also, moderate. You can give your suggestions. Similarly, each one of you can give thoughts. You don't have to restrict only to a few of us. If you are knowing the subject, please give some suggestions. Okay, Shifali, go ahead.
Yeah, thank you so much, everyone. Thank you so much, Silvamurthy sir, for joining this mock presentation. So we are meeting again to have our mock presentation of all our presenters who are proposed to join during our ISRO Amity joint workshop planned on 15th May at our Amity University Bangalore campus. And we have also been joined by Dr. Silvamurthy sir as a esteemed panel member, along with Dr. Neeraj Sharma, Dr. A.K. Singh sir, and we have also requested Dr. M.K. Datta sir and Dr. Prasad to give their valuable suggestions on the presentations of all our presenters. So without wasting much time, I would humbly request, as our first session will be on artificial intelligence in space science and technology, application of artificial intelligence, space science and technology. So we are proposing that we're going to start our Amity presentation by Dr. M.K. Datta sir. So I would humbly request, sir, you may kindly upload your presentation. Then after Dr. M.K. Datta sir, we'll be having the presentation of Dr. M.S. Prasad sir along with Dr. Shivani madam. So we have proposed in artificial intelligence, there will be 2 presentations from Amity side. So, sorry sir.
Shifali, I just would like to give a little brief to them, if it is okay.
Sure, bilkul sir, bilkul. Yeah sir, please go ahead sir.
So first of all, I welcome every one of you. You have made a lot of efforts to prepare your presentation, our deep appreciation. And also I convey the blessings of Honorable Founder President, who just had a 1-hour discussion, about this ISRO workshop just about an hour ago. He spent a lot of time and also addressing who are all their expertise, how we should present. So I will share some thoughts which he has expressed. The first thing is you should look at ISRO website thoroughly, understand which are the institutions in ISRO, which are the programs, which are the thrust areas, everything you must very clearly be thorough about. So please spend time to go to the ISRO website so that you should relate your expertise and presentation to that. This is one suggestion which has come from founder, you should visit. Second is, you should also see top 10 space agencies. There are like NASA, European Space Agency, Australian Space Agency, like that. There are top agencies, Chinese Space Academy. So all this, you should visit their site. We will, Shifali, you forward to everyone these websites so that they see this and they should relate. In this area, China is doing this. In this area, NASA is doing that. And we want to do something different from Amity in this domain. So every one of you should be thorough with this. So please not only prepare your presentation, be thorough with this. Because whenever we go to such presentation, we should be professional. So the second suggestion is understand the top 10, what they are doing in your area, what you are going to present, whether it's data analytics or AI, whatever is in open website publications, please visit. This is the second suggestion. Third is limit your own competence and achievements, because we will be in any case giving a profile of the people going there, making presentation. So your competence and contribution should be highlighted for maybe 1 minute or 2 minutes, but elaborate more on challenge, grand challenge, which you are going to address, which is relevant to ISRO and our space research programs. Then highlight what is the novelty in your approach. This should be the framework of your presentation, like last time said, but founder made it very clear today in our deliberation, these 3. So visit website, ISRO website, see the space agencies, top 10 agencies, understand in your own domain. If it is AI, what the others are doing. Third is the scheme of your presentation should be very brief about your showcasing your strength and competence, which should attract them. It should be brief, concise, but elaborate more on the space program, which is very relevant to the presentation. They should say, I want to work with Datta. I want to work with Prasad and Shivani. And because this is something new they are telling. So this is what we are expecting from your presentation today. And so maybe we'll have one more presentation on 8th, the final presentation, but we like to listen to this. I think Dr. A.K. Singh would like to further elaborate. More to you, Singh, sir.
I said just taking your comments a bit ahead to make things a bit more simpler. I think first, that's not the platform where we should be projecting, highlighting in detail about who am I. But certainly we have to succinctly convey that who am I, what are my accomplishments. I think then the little more emphasis on your technical expertise means the area, because when you say area and what you have accomplished, because that will give them understanding of our strength, or including any earlier collaboration which we had, any interaction which we had either with the ISRO, if not with ISRO, with NASA or any other space agency. Then extending your expertise and accomplishments to suggest them that how you would be able to provide them the solution or help them in accomplishing their objectives in the projects, or how we can have a collaboration, or how my expertise can give extension to their understanding, and how it will be useful. And if there is a new idea which maybe look like a new idea which they have not explored, or I feel it may be, so very some strong confidently we can say I feel that this could also be done. So that is my submission. So you must have incorporated all these things, because we had discussed this thing in our first round of discussion. If not, please keep it in mind so that we all are on the same page, because in whole workshop the presentation by our esteemed faculty is going to be the core and decisive factor of on that day. So basically everything would be driven by your presentation and the engagement. Keep your presentation not more than 15 minutes, because each session is 90 minutes, 1.5 hours. So what I was thinking, 15 into 4, 2 speakers of Amity, 2 speakers of ISRO, 15 into 4, 60, and 30 minutes we can keep it as a buffer or a discussion. So I think we should not go in any case more than 15 minutes. Let's try to restrict our presentation within 15 minutes. That's all. Over to you, Shafali.
Yeah, thank you so much, sir, for your
I
remarks,
think
sir. Can we
Neeraj
have,
Sharma wants to say
yes,
something, Shafali.
can we have Dr.
Thank
Sharma's and
you.
Dr. Khatri's remarks also, sir?
Thank
Sharma, sir,
you.
please.
Thank you, sir. Thank you very much. I will not repeat whatever has been said, but ultimately from this workshop, which is going to be the first workshop with ISRO and Amity, what are we looking at? We are looking at first an outreach center, which should come from the ISRO to us. And second thing is a number of projects that few projects have already been submitted. Number of projects should increase under the respond call or other calls, that we should be able to get research and development projects. So these two are the basic fundamental things, apart from an MOU which will come later. I think that we will have to see. And as Dr. Singh said, we need to show our strength, and we also need to show our synergistic efforts between Amity and ISRO. So with that in mind, and also one more point I want to emphasize, as Dr. Singh has also emphasized, the timeline, the time of presentation, the time of the event. You should keep this in mind, that you should not be exceeding the time limits, because that will not be in a good taste when the time exceeds. If you're given 10 minutes, please restrict yourself for between 10 minutes or 15 minutes. Let the other, take over from there. So that these are all points I wanted to make. Thank you.
Yeah, thank you so much for sir for your remarks. Dr. Khatri?
Yeah. Today also morning we had a discussion also on this, and I think one point which I would like to emphasize more is, as discussed, that we should focus not more on what we are doing, rather than focus on what we can do or want to do with ISRO. So in which areas we can collaborate. Our presentation mostly should focus on these. For example, if we are speaking for 6 minutes, then 4 out of 4 minutes should be on what we want to do with them and how we can help in their research problems rather than what we are doing. So the presentation has to be made in that way. And as already mentioned earlier also by Dr. Singh and Dr. Neeraj also, that our presentation should not be that lengthy. Rather, we should have time sufficient for them to think or some deliberations also on that.
Right. Thank you. I think, Shefali, we will also listen to Professor Prasad. He is
Yes,
the
sir.
director of Amity Institute of Space Science and Technology, and he has a lot of connectivity with ISRO. He closely interacts with them. Professor Prasad, just initial brief
Sir.
remarks, and then because you know all the challenges of ISRO and you are thorough with all the other space agency, including Cosmos, the Russian space agency, you are interacting with them. So some initial thoughts, then we will listen to the presentation. Prasad.
Thank you, sir. Good afternoon, everybody. Thank you, sir. Sir, there are a couple of points I would like to say because I keep interacting with ISRO and some Russian agencies also. They are looking for collaborating with us. Say, what is the ground for collaboration is that two of us are interacting with them for last 2 years. And before that, I was doing it alone on a different capacity. They want to collaborate, but the problem they are finding out on which domain. And they are now focusing on AI because if you see the Respond 2023, they have put 15 problems which is revolving around artificial intelligence and data analysis. That's why they have asked us, because when I talked to them, I told them that we work on intelligent systems. So they are requesting us that can we collaborate with them. About our laboratory, they know, sir, but we can always give them a presentation about this. My request would be just be focused. We cannot utilize the time for everybody presenting this. Keep minimum people, sir, and focused approach. That yes, we have an expertise in signal processing, radar signal processing, artificial intelligence, data analysis, maybe astrobiology, what we are saying. And this is our focus area on which we will collaborate. And the focal point could be your office or somebody, and we can keep going there and doing it. That is my request.
Very good, very good. I think you can also keep giving. You can keep giving the relevance of these presentation if they are missing out the relevance of grand challenges.
What I am doing today, sir, I am noting down all the presentation. I am noting down all the presentation today, sir. And then I will make a collaborative one big presentation, very little as Dr. Neeraj sir has said, that about 15 minutes, which will focus on Amity's capability in these three domains. And then we can start discussing with each other.
Very good. Shefali, now with this, we can start the presentation.
Yeah,
good.
Thank you so much, sir. Thank you.
I wanted this to come. And also, you can give a colloquium after you listen to all this, maybe on 8th, that what are those top 10 space agencies are doing and what are their priority areas in these three domains. Like if it is AI, right, what that Russian space agency is doing. I think Sudhir Kumar ji is calling. I'll take the call from ISRO director.
Yes, sir.
We can give
Sudhir
it,
ji?
sir. Sorry, Shivali. Sir, we can
What a
give
pleasure.
it because I'm an advisor to European Space Agency also. We can do that.
Yes, sir. Singh sir, I think we should wait for Dr. Silvamurthy sir to start with the presentation, sir.
I think Dr. Prasad is there. Let's continue. We will brief him if there is any important point because he may take 10-15 minutes. Everyone is waiting because already he is aware of all the activities now. This is my submission.
Fine. So we are starting with the session 1, application of artificial intelligence in space science and technology. And we would humbly request Dr. M.K. Datta sir to kindly upload the presentation. Datta sir.
शेफाली, इसका टेम्पलेट एक बना दो सबके लिए।
Yes sir, आज इवनिंग में हम लोग सर्कुलेट कर देंगे सर. We have
हाँ.
circulated the template, but एक फाइनल हम लोग iMagic से डिजाइन करवा के will share by today evening sir.
Right.
Datta sir, I think we can start with your presentation as everyone has suggested so. After Dr. M.K. Datta, we would humbly request Dr. Shivani Verma to be ready with your presentation.
Dada, put it on slide display mode. It will come. Dada.
There is some issue in the.
हाँ, slide mode में डालो. हाँ, click कीजिए उसको. आ जाएगा.
Sir, click कर रहे हैं, issue आ रहा है शायद. Puneet, can you help?
थोड़ा टाइम लगेगा.
मैम,
वो
जितनी
ये हटा लो
बहुत
ना.
सारी प्रेजेंटेशन खुली हुई है, उनको एक बार क्लोज करेंगे फिर ओपन करेंगे.
अब
अच्छा.
उसको हटाओ. प्रेजेंटेड बाय हटा दो. इट इज एन एडिटेड मोड. उसका जो बाउंड्री बॉक्स दिख रहा है, प्रेजेंटेड बाय का बाउंड्री बॉक्स अभी आ जाएगा. अब दोबारा कीजिए. Wait. Now go.
Now, is it in the full screen mode? सर, उस पे
Yes, sir.
प्रेजेंटेशन पे राइट क्लिक
आ
कीजिए
गया.
सर. आप प्रेजेंटेशन पे राइट क्लिक कीजिए, उसका हाइड प्रेजेंटेशन आ रहा होगा, वो फुल स्क्रीन में आ जाएगा.
आ गया.
Is it in the full screen mode now?
हाँ, we can see the slide.
Sir, your first slide is AI and space exploration.
Is it in the full screen mode?
Yes.
Yes, sir.
Yeah. Or is it some
It is
side?
in the
The presenter,
it is in the notes mode where one can read the notes of the slide. I think you go to the other mode. It is not.
ठीक है. You can see the slide.
सर,
The
वो
presenter
दिखता है, वो
mode में open हो रही है slides.
put it here and then what is the problem? I mean, is it visible now?
Yes, sir. It is
चलो,
visible.
But
I
is
think
it
go ahead like this. Go ahead.
This is how it is done. No problem. वो next slide है ना.
but
ठीक है. That's all.
why am I not able to put sheet in the full screen mode?
Sir, are you using dual screen?
No
I'm
problem,
using-
Dr. Datta. Dr. Datta, no problem. You go ahead there with that.
Okay. Okay, so good afternoon to all of you. So I'll just proceed. So I have prepared some slides, and so I'll take 15 minutes. So I'll run through the slides because there are a few more slides. I'll give you the basic idea. So let's proceed. So this is a slide about our center, but anyway, I'll skip it. So this is my first problem. Is the first problem visible? I'm showing
The slide.
space knowledge unlock. Is
Yes,
the
sir. Yes, sir. It is visible, sir.
Okay, great. So good afternoon to all of you, and this is my first slide. So you see, this is what we're trying to do here. We are proposing here that a lot of information in space knowledge. So 2020, 21, you must be knowing that transformers have come up. You know, the LLMs have become very powerful, and you can train a lot of models. Like we have got user friendly, free models like Llama 1, Llama 2 from Meta. We have BERT from Google. So what I'm proposing here is that I'll take a lot of space literature. Okay, I'll take a lot of space literature and produce it in such a way, fine tune a large language model in such a way that it becomes a chatbot for the space scientists, professionals, researchers, or the agencies. So in the current times, if you ask a question to ChatGPT or Llama 2 or Llama 3, a question, as a chatbot model, most likely it is not going to give you a precisely correct answer, but a fine tuning of that model. So this is what I'm proposing. So requirement, the trainable data will be research papers, textbooks, website contents, and very categorical, content on space. And the methodologies will be, currently RAG models have come up, the retrieval augmented generation models, LangChain, and other models that we can use to fine tune a model so that it becomes a very user friendly and a useful chatbot for space agencies. So this is number one. So this is a very latest technology which has come up in 2021, 22. So Llama 2, Llama 3 has been released only in 2024. So most likely we can use that, the free software. Second is second is a similar thing. So what here we are proposing is that summarization of a mission. Like for example, let's say for example, there was a mission and a lot of data has been generated, like space related scientific paper, there are reports and logs, there are generated during the space exploration, and now you want to make a report. Or let's say you want to make a report out of it. Let's say you have got 5,000 page data, you have got 5,000 page log sheets, you have got 5,000 page of data that you have received from the sensors, and most likely the other I want to hide this. So how do I hide it? Anyway, this, the LLM models, the LLM, the large language models that has come up, actually the transformers, we can train and fine tune transformers to make customized report. Let's say you want a one-page report. You can see my left hand side of my image. Let's on the right hand side. Sorry, the left hand side image. The first image is if my slide is if my pointer is visible. So you can see here, if I ask a one-page report or a summary report or a four-page report, or ask him, give me the experimental report, give me the theoretical insights. So customized report generation can be done. Let's say we have got all information. So this is once again an LLM model. Very recently, these models have come up. This is actually the attention model that have come up, and transformers have been, So the expected outcomes are development of robust LLM-based algorithm for automatic summarization of space mission report. Let's say the minister wants, or the director of ISRO wants a one-page report on a specific content, like what was the reason of the failure, or give me the experimental data set, give me so specific report generation automation using large language models is my second proposal that I'm trying to show you. The potential impact are facilitators, quick and informed. For example, if you want to put a scientist to write a report, right? You'll take 5 days, 7 days, 10 days to read all the 5,000 pages data and generate a report for you. So this we can do it within no time if you can train the models properly. This is my second proposal. The third proposal is I call it as AI super, like, it's about precision agriculture. If you have got images from the spaces, from the satellites, we can train model for predictive modeling for crop management, yield prediction, and satellite images can be used for that. So currently, if you see the powerful AI models like vision transformers and other developed models, so most likely automated crop monitoring and yield production, and also it will aid for in precision agriculture and improve farming. This is my third proposal. The fourth proposal is on debris detection. I discussed this. This is pretty simple. Like I think in the last, we have some information in the space also. So most likely we can do some AI modeling so that the satellite can remain free from debris. And this is a known problem. I think this is quite a known problem. Here we come with AI. I'm having a problem to handle my screen. I don't know why.
It's okay with that. Go ahead.
Just one second. So AI-driven optimization of surface engineering for space applications. So what I do here, what I mentioned over here is that all these I've taken from the ISRO literature. Like when a rocket or a satellite is to be launched, there are a lot of surface engineering done, like electroplating, maybe thin film technologies. You bring in painting, you bring in spacecraft, and on the basis of that, the aerodynamics of that spaceship and the space vehicles will be controlled. So what I say here is that if we can have the data for that, relevant data for that, we can develop artificial intelligence and machine learning models to optimize surface engineering process for spacecraft application, enhancing the efficiency and reducing resource expenditure. Because if you want to do it on, let's say you want to do it on in a conventional manual method, it may be more. So if you have most likely images or any tabular form of data related to the surface that is expected out of a spacecraft, if you have that data, most likely we can do it, and it might impact informed decision making. Yeah, optimized surface engineering will enable some informed decision making for future space missions and ensuring reliability and performance of spacecraft components. So my next proposal is I showed this in the previous day. It's about rover, like tragic. Let's say if we have information about the surroundings of how a Mars, a lunar mission, or a Mars mission looks like, how to train a rover. Of course, these are ongoing projects, but once again, we can say like inverse kinematics problem, how the joints will be moving. For example, let's say in the right hand side down below the the is actually about XYZ coordinate movement. We call this inverse kinematics problem. So if you can train robots, if you can train robots, to find proper trajectory, avoid terrains which may actually be damaging this rover, most likely we can train AI models. Of course, AI-driven advancements for this robo kinematics will contribute in mission success, by enabling some precise navigation, and of course some resource utilization also can be done. So this is not new. People are working, but we actually make unknown location for, let's say, lunar, something like that. So this is about change detection. So this is from the ISRO response basket. If you look into this satellite imagery, once again, if you can look into this, how the changes are forming, you can see the left hand side of this image. Is my laser pointer visible? Can you see my laser pointer?
Yes,
So this is how the previously satellite image looks like. This is how the next looks like, and this is how the difference is like. If you look into, if you want to find out some urbanization problem or agriculture related problem, how the changes are happening, and most likely the space agencies are interested to know how the changes are happening over a sequential period of time, and how you can predict. So enhanced environmental modeling this is taken from the uh, ISRO basket, that response basket. Now we talk about remote sensing data analysis. This is a big umbrella actually. When we talk about remote sensing for data analysis, we have got models like AI techniques to enhance the analysis of data from remote sensing. The data can be a continuous stream of satellite imagery, or it can be sensor data that is transmitted over a communication channel. And most likely we can use APIs and data services to provide access to. And this diagram, if I have time, I can explain the models you have, the volume of data processing and handling large data sets, the real-time analysis, the multimodal data integration, because here the multimodal comes into picture. It's not a single, let's say you have got sensor data, and you've got imaginary data, and you want to take the decision on the basis of the sensor data as well as imagery data, the images. Most likely you have to go for multimodal classification. And with the current transformers that are available in the last couple of years, we are capable of doing that. Predictive maintenance of spacecraft. Let's say the spacecraft is on board, and from various sensors, this is not new actually. I've picked from the ISRO response basket. Once again, you see, if you have got a continuous access to the, let's say, the telemetry data or the maintenance logs or the operational parameters, so based on that, models can be trained, to predict rather than a reactive, operation. Maybe a predictive or a proactive operation can happen, and of course, the outcomes can be reduced operational cost, mission safety, and you can minimize risk of unforeseen technical issues, data-driven decisions, and scalability and flexibility. So this is another thing which you can look into it. Of course, if you have got adequate amount of data, you can process that. AI for planetary exploration and geology. Now, this is like, to develop and implement advanced AI-driven analytical methodologies that can efficiently process and interpret geological data from the planetary surface. Like you want to know if that planet has water, if you want to know if that planet has mineral resources, you want to know what kind of information is there on that, surface from which the rover is going to pick the imagery and other sensors. So most likely you can have data requirements of geological data from the planetary surface. And if you have data, the complex patterns from which, if you can pick patterns to detect and analyze complex geological patterns in real-time analysis, if you can do that, of course, the nature of the data expected to be multimodal data. It will not be a one-dimensional data, and maybe some very powerful models like deep reinforcement learning and federated learning, etc., can be used to most likely the space agencies are interested to know what kind of geology the surfaces are available on the celestial bodies. This is one problem. AI in satellite constellation management. So where you deploy 10 satellites or 100 satellites or 50 satellites in a constellation from a spacecraft. Now, the optimally, how do you locate these spacecrafts? So that you have got a better bandwidth coverage. Okay. So the dynamic resource allocation, we want that the satellite should maintain certain geographical locations so that there is collision avoidance. You can utilize predictive analytics to anticipate and avoid potential collisions, automate the orbit adjustments, real-time processing capable of processing vast amounts of telemetry data so that, like it can cover a maximum. Let's say I deploy 10 satellites. It should be positioned in such a way that maximum utilization of that data. So increase computational efficiency, enhance coverage, consistency, reduce collision risks, and improved longevity of the satellites if you can go for a task scheduling problem for that. AI for enhanced communications systems. Now here, let's talk about delays. In any mode of communication from the satellite to the ground station, there's a delay. Let's say there's a delay. There's a signal degradation. There's a noise interference. There's a clutter. Let's say. Now on that, the interference or the inferences that have been generated from the space signals may be affected or impacted. So we can use LSTM models, predictive analysis. We can use LSTM models. We can use attention neural networks. You can use any, there are many deep neural networks like attention models have come up, which is based on contextual memory. So if we have a memory of, let's say, 24 hours of data or 10 hours of data, and there is a blip for 5 minutes or 10 minutes or 20 minutes, most likely we can recover and predict what was the data that was during that blip. So gather extensive data sets from space communications and inclusion of instances of signal degradation, inference patterns. And the outcomes can be improved data transmission reliability, increased communication quality, reduced latency, and more utilization of the bandwidth available. This is one single diagram. You can see I have picked it from one of the websites. I'm going to redo this slide. Satellite imagery potential problem. Every problem is a problem on its own. Okay. You talk about urban planning. You talk about urban waste management. You talk about tracking carbon emissions, vegetation monitoring, railway engineering, infrastructure monitoring in railways, prediction and direction of natural disasters, railway obstacle detection, infrastructural conditioning mapping, and for airport mapping. So this is 10 top applications of satellite imagery. Okay, now this may involve some availability of data and train with models like convolution neural nets, transformer, vision transformers, and expected outcome can be contribute to sustainable development goals. I think all these are actually covers in the sustainable goals in the ISRO mandate. So this is purely aligned with the ISRO mandate. The impact may be enhance the environmental conservation and infrastructure resilience, enable data-driven decisions to make sustainable development. This is hyperspectral because satellite images. The previous slide was all about visible range images like camera images. If you talk about hyperspectral images, most likely you can go beneath. Hyperspectral is about frequency and spatial as well as frequency. You can see beneath. For example, look into this hyperspectral cube. So hyperspectral imaging data can also be modeled with. You can see this slide how the different objects looks in the hyperspectral image. And for example, interesting example can be for let's say there is a camouflage army vehicle. Let's say there's a camouflage tank. Let's say there is a camouflage tank, which otherwise from the top looks like a vegetation. Let's look like some plants, etc. But then with this hyperspectral imaging, you can actually locate. Now, potential applications can be soil mapping, methane detection, coastal monitoring, crop classification, oil spills, biomass, camouflage tanks, and based on this hyperspectral signatures. And hyperspectral signature goes beyond conventional, imaging in the VIBGYOR region. Most likely, you can have specialized applications once again available the data, and we can see how we can train models. The impact can be accurate analysis of this hyperspectral data for sustainable management of natural resources, leading to improved environmental conservation, disaster resilience. Most likely, many if we talk about it. This is interesting. So I talk about AI-based data compression for faster and efficient space communication. Now, let's say you are sending a space images are of GBs. Tons of data are transmitted from the satellite to the ground station through some channel. Now, the new methods have come up. Autoencoder. There is a new technology have come up in 2017-18 autoencoder. Autoencoder is based on some latent variable generation through where you can actually compress the data. For example, you want to transmit a satellite data. Okay, the satellite data maybe of 2 GB or 5 GB. It may have huge volume of data. So if you can actually tune, let's say, if you can tune autoencoders, if you can tune autoencoders or variational autoencoders, so what happens is like you send us, we will from the satellite, we'll get an encoded compressed input, and at the ground station or wherever required, we can actually generate it, with a decoder. So that may lead to optimized bandwidth utilization, signal integrity enhanced, adaptability to various conditions, and more importantly, the best utilization of the allocated bandwidth. This is about your landing sites. Like if you have data, let's say there is a satellite which is supposed to land. Now, even before the satellite is going to land, it has to avoid the terrains. It has to avoid some kind of unwanted locations where the rover may not get a optimum place to move. So the objective is utilize artificial intelligence to analyze the data from lunar orbiters and rovers to characterize potential landing sites, because from the rover we already have having data. The rovers that have been sent on space by India and other countries, they're already sending us data. So if you can train the model that look, if there is a hole, if there is a terrain, or if there is an elevation, we do not want the satellite and they're both way, the satellite to land and the rover to open. So both these things may be interrelated. So convolution here, and if you have information about how let's say talk about a lunar mission. I've written lunar, it can be Mars, it can be any celestial body. Let's talk about Mars, or you talk about lunar. How the surface of lunars look like. In case if we have adequate information about it, we can actually indicate the satellite, the landing spots on lunar, or any celestial body like Mars, etc. This is about because you see, and the problem here is like in the world, in our Earth, we have some layers like troposphere and ionosphere and some spheres through which the sunlight enters and some radiation, some filtering, etc. happens. Now in the open space, if you're exposing your electronics in the open space, when you're actually expose your electronics or any mechanical system, let's say we're talking about a solar flares, there's a chance of degradation or defect generation. So this is an interesting idea where I can say that most likely we can use AI algorithms to forecast space weather phenomenon like solar flares and let's say geomagnetic storms. By analyzing the data from satellites and ground-based stage sensors, most likely we can model it in such a way so that we can give indications to the solar vehicles to ensure that they do not enter those kind of situations where their health is impacted. So outcomes data can be like the previous data that has been collected. We can train recurrent neural networks or any attention models or any transformers, and possible outcomes can be early warnings. To make about space weather events. Let's say there's a solar flare. So if the satellite has information, maybe it'll try to counter that. So mitigating potential damage to satellites, power grids, communication systems, because the electronics is directly exposed, improved accuracy, enhanced preparedness, and of course scientific insights. Okay. This is about the defect detection and quality. Let's say I have not seen a spaceship on my own, so I don't know. But what I know is that spaceships are very big. Spaceships are very big. Satellites are very big. So if we can also automate, the final quality control check of a solar vehicle, of a space vehicle before it actually is goes to the mission, using automatic machine like let's say computer vision methods. Possible AI and deep learning algorithms can be used. Conventional methods like CNNs or faster RCNN or yellow models or deep belief networks can be used to implement AI-powered vision systems for defect detection and quality control. During spacecraft manufacturing to ensure high quality maybe during the manufacturing, and also the people who manufacture them, we can also deploy them to ensure the quality support of that. This is about let's say we give them a wearable jacket. For example, the space astronauts, if they wear a wearable the dress, inside from that dress we can pick the main body vitals. Let's say the EG, ECG, or other, like let's say the the blood pressure or NIBP sort of information we can pick. And on the basis of that, we must be in a position to make AI models to predict not only the physical health but also the mental health. Whether this astronaut is now, I think in the ground stations, I don't know, I do not have a personal experience of doing that, but in the ground stations in European, let's say in NASA or in European Space Commissions, they have those. And India, I think, have committed that by 2030 they are going to make this in our country. That's what I was reading. India has committed that 2030 you will have got space training stations in our country. So these will help. These models will help automatic transmission of body vitals, and most likely that the crew members' health and well-being during the space missions. So continuous monitoring, early warning systems, personalized health assistance, and of course we can make automated decision support on them. And outcomes can be early detection of health issues. When I say health issues, it can be mental health issues also. Like if somebody is into, what I was reading in some of the books, that they feel detached. The moment these guys goes in space, they feel detached and they go into hallucination, some, I don't know, hallucination and some other kind of issues. So those things we can detect from the body vitals. And my last proposal is, this is about satellite. This is related actually. One slide I showed you 10 problems, possible problems, and here I show you, actually they are related, because the data that you get for those 10 problems I was showing you for satellite imagery, you need to upgrade them, enhance them for processing. So this is where I'm proposing, how can we enhance a lot of AI models have come up now. I think a lot of AI models have come up for image enhancement model. I'm just trying to show you a convolutional autoencoder, which is very popular. This is the basic model. If you know the nature of the data, we can actually tune a convolutional autoencoder into more sophisticated and customized model by fine tuning, and enhance the resolution of quality of satellite images through advanced image processing techniques, computer vision models. Proposed methodology, I have mentioned some autoencoders we can use, and possible outcomes is like enhanced quality of resolution for satellite images. That slide where I have shown you 10 satellite imagery, and these are interrelated because you need to improve the resolution for making better decisions. So that's also, I have got 24 slides. Now I'll share the slides with you people. You can tell me which to be included or combined, etc. Maybe after seeing that. So that's it from my side. Thank you.
Very good, Dr. Sir. Very good. Now, before I give my comments, I thought I will request others, starting with Prasad and others,
Yes,
so that
yes,
then
sir.
I will
talk
give
to
my
Dr.
thoughts subsequently. Over to you, Prasad.
I will. Sir.
Just stop sharing
I will
slide.
talk to Dr. Datta also. Datta Sahab, what you have done, you have covered the entire bunch of artificial intelligence which is applicable in space science. Couple of them we are already doing. What I will request you that I will come to your office and make a precise PPT, because this PPT has got a lot of information, but we have to put it as a bullet point, especially like crop detection we are already doing, debris we are doing, surface engineering, yes, you put it that we will develop a system for surface engineering. Then you like change detection we are doing, and predictive analysis. You can say satellite constellation management, enhanced communication system, hyperspectral. We will show you what we have done. We will take, because in each we are writing that we have got a artificial intelligence center where we generally do the work. Lunar landing, we can do it. AI-based data compression, generally we don't do in a space, because a space data format is different and its accuracy and bandwidth is different. That's why we do not go for any normal compression. NASA has come out with one of the compression technique which is used by almost everybody. Quality control, yes, we can put across. And health monitoring, we are putting a proposal. I will add your name also. Satellite image enhancement, yes, that is GAN network, super resolution satellite image. We made it for Indian Air Force and Army. We can also tell them that this we are doing. So please give me some time tomorrow when I can sit down with you and make precise 5 to 7 point-wise slides with you. Now, we will do it, sir. I will go to Dr. Datta office and make it,
About that,
very neat.
What about the LLM models, the earlier LLM models that?
Yeah, first one, I forgot. I will come to your office and make it with you. No problem.
LLMs are still unexplored. I don't think people have actually used LLMs.
I will sit down with you. I have noted down all 24 slides ready. I will sit down with you, make a compact one and do it for you.
Thank you. Dr. A.K. Singh, sir, and also Dheeraj ji.
I think I congratulate Dr. Datta for elaborate presentation. I think he has covered, I think he has flagged all the applications where AI can be deployed. But,
Yes.
2 points. In Dr. Datta's case, because the center is also the strength of Amity, and that differentiates us. Dr. Datta, would you mind including one slide where you say the computational facilities which have been created and which are at our disposal? One. This is my thinking. One. And then I think we need to showcase that what we have done till date, because in all your slides you are flagging this is one of the applications, then these are the objectives, likely models, and the outcome. So okay, wonderful, but we have to say somewhere why ISRO should hand over the assignment, these problems to me, because I need to say that I can do it better than others. So that part is missing. Point number two. Point number three, the slides. Okay, you have said that these are all your slides which are to be shortlisted. I think Dr. Prasad would be doing with you. I think थोड़ा सा slides ना मुझे cluttered लग रहा है, इसको थोड़ा और decongest करें तो थोड़ा अच्छा रहेगा. Otherwise you have done a wonderful job and I appreciate and I am impressed.
Thank you. I think
I
very
will get
precise,
it done.
good suggestions, Ajay. A.K. Singh sir, and now Neeraj ji.
No, I think Dr. Datta has rightly, understood the issues and challenges, and he has depicted them in a very, very, in an apt manner. I would like to only add a few topics which could be of some sense to. I think he's covered, but there is some topic related to river linking. It could be one area where we can work with agencies, government agencies, or something. This data, how the rivers are changing their course and how can we link them. This could be one area through artificial intelligence. Then the groundwater availability is a huge problem these days. The groundwater is going down and down. Can the artificial intelligence through the satellite imageries? Of course, you have covered the garbage waste management, water bodies. There are other things which is storage facilities. Can our satellite imageries tell us where are the storage facilities for farmers? I think this is one domain which is very, very, very much required in India, because farmers are not able to get the price because of the mandis are far away and it is costly for them. Can they store at their own places and so on? So what is the data that tells us in terms of, and other things which are, I think, of some use or maybe little use in agriculture, which is soil type, land size, machinery that the farmers are going to use. I mean, these are some of the satellite imageries. If we get that data from ISRO, we can do a wonder in artificial intelligence. But fantastic presentation, Dr. Datta. I think you have made brilliant. I must say that. Yeah.
Thank you. Anybody else would like to make any comment? Just raise your
Sir,
hand.
one thing.
Yeah, please.
Sir, just a minute, sir. Is it band ho gaya? Sir, what is happening? Dr. Neeraj, sir, most of the time what happens, is it mute?
Yes, please. Yes, we can hear you.
Sir, what happens most of the time that ISRO supplies the satellite image.
Right.
Their site is known as Bhuvan.
Yes.
Bhuvan is the site where you get all the images. Hyperspectral image only comes from NRSA Hyderabad. Sir, all these problems, what you have said, river linking and groundwater problem or couple of problems Dr. Datta had said, there are different agencies who are dealing with these problems. Like, sir, Indian Institute of Remote Sensing, Dehradun, does the crop detection with the synthetic aperture radar image. Dr. Shivani has done some project with them. So they are also working on that river linking problem, sir. But ISRO per se does not go into solving
No, I
the-
understand. I understand what you're saying, because the recipient of these information would be
yes,
some
sir.
different
Yes,
ministry.
sir. That we can say.
ISRO
That
can
we
only provide you imageries, right? That
Huh.
interpretation of that data through AI
is to
is
be
our
done by
work.
us.
And at
Done
the
by
same
us.
time, I agree with you, but there is a duplicity or multiplicity which is also required in India, because there are
Yes.
multiple agencies or multiple institutions maybe working on the same topic, on the same
Thank
subject.
you. Thank you.
Yes, sir.
We also welcome Dr. Santosh, the Vice Chancellor of Amity University, Mumbai. Santosh ji, Wilson ji, namaskar. You have joined, na? Dr. Santosh?
Yes, sir. Dr. Santosh,
I'm there, sir.
Santosh sir
I'm
has
there,
joined, sir.
Hello?
Okay.
Sir, I'm there.
Now, let me just give my thoughts. I listened to all your wonderful, very wise suggestions you gave. Datta, again, compliments. I join everyone to compliment you. You have really made the spectrum of AI application, what all Amity can do as a basket of potential areas in which we have expertise and we can do that you have already presented. But now I would suggest, having given the breadth, you also focus on 2-3 areas in depth. Supposing you choose the health monitoring of the spacecraft, not the astronauts, monitoring of the surface engineering, health of the aircraft, any problems occurring in between. So then go, how you would do it using the AI tools of yours. What is the problem you will attack? And then what solutions you will give in a depth, so that they know, understand that this is how you will approach. The process by which you will give them a solution should come out in your presentation also. So select which are the 3 areas you have given a spectrum. Now in that, where you have strong expertise and there's a strong need. See, all these potential users for change detection or agriculture, the users are different. They are ultimately using the ISRO data. But what ISRO wants is, what is that we can do to do their mission? Say, like, for example, enhanced communication is very important. So how do you communicate from satellite to ground station? How do you ground station to that? So how would AI play an important role? Even if there's a break in communication, how would you fill that gap? Is very important, so that they get the total picture. Can AI fill that gap? So like that, choose that area. And how would you fill, like CRISPR-Cas? You cut this and re-edit the genes. So something like this, can you bring the communication, fill the gap if there was a communication gap? So like this, select some 3 areas where you will elaborate in depth. This is the challenge. This is the solution I have. This is how I will approach. This is what ISRO will get the benefit. So this is one suggestion. Then the second suggestion is one area which is important: predictive maintenance for spacecraft. This is again a very important domain. Then rover kinematics. Rover, when they are there, how would you make it successful? It should go to the right place, whether it's for mineralogy or it is to avoid the obstacles. And if there's any hazards, prediction, and then avoid that. These are all very important, relevant to this. So I would suggest the other beneficiary, like remote sensing, change detection, all that will come in the user. But select directly, ISRO will be benefited, and focus on that. So narrow down from this basket of 10, 12 areas to 3, and then you can present the basket very quickly. These are the expertise, but I'm now going to deal in depth in 3 areas where we can launch this program, which has a direct benefit to ISRO. So this is my suggestion. Okay, now, Khatri, you have anything more to say? Very important.
Yes, sir. It was a very wonderful presentation. I am just having 2 points. One thing is, Dr. Datta's presentation is so elaborative. I fear whether other may have some redundant points to be covered. So we have to see that anyone else should not speak the same thing, so that we can optimally utilize the time for discussions. Second thing is number of slides. I can see it's the 24 slides. I don't know whether we will get that much time because Dr. Datta would have so much to share on work he is doing, what all he can do. So with less number of slides, he may have more time to discuss or explain. So we can see that possibility, Dattaji.
Good. Now, Santosh ji, your comments, because you were also listening to that, or you just joined, Vice Chancellor sir?
No, sir. I was actually listening to that, sir. I was in an inauguration though. So I was just looking at the whole presentation of Dr. Datta. In my opinion, if it could be little more focused towards the AI part with some applicability will be really good, because the slides, all the 24 slides were very, very good. It was covering many of the aspects. But if we are going to just focus on the AI part with regard to Astro, it would be very fine. That's my small suggestion.
Good, very good. A good suggestion. And AK Singh, please.
Sir, I also want to submit, I totally agree what you said, that the whole canvas, then focused targets, because there would be a discussion also. I think we have to bring out where this proposal stands in India, abroad, and in what way, specific, how we would be taking it ahead, because they would like to understand more, may go to second level of questions and to the third level of questions. So, we should be, prepared for that also.
Right. And fortunately, just now that Sudhir Kumarji himself called. I was planning to call in the evening. He himself called, is the program okay? And all that he asked. And then I have requested him to send the profile of the scientists who will be coming from ISRO side, little bit of profile. And so he is sending a mail to all those people looking at the program. And then also chairman himself may stay longer, up to 12, he said, certainly he's there. From 9:30 to 12, he is with us, but he is also trying to explore whether he can stay till lunchtime. So first technical session, we have to make it very impressive, because he will be there maybe a few, even if he stays up to 12, we would have started the first session. So that is why he will be there. But certainly he is trying to, I have requested him to explore whether he can stay till lunchtime, which he will be exploring.
And Dr. Datta is going to be the first speaker as per the program.
Yeah, let us see whether Prasad also, we'll see that whether Prasad, after we know that after 8 presentation, we will see whether
I think, sir, can I just interrupt you?
Yeah, please.
I think, sir, at this stage, we also need to see who will be the co-chair of these sessions. You see, this is very important. We need to discuss and rediscuss on this aspect as well, because many times we may not just be representing Amity, we should also be representing the subject area and the domain.
Yes.
So that is very important. I've been telling Shefali about this, that the area's expertise or subject expertise should also be considered when you consider person as a co-chair of that event.
Absolutely.
I'm talking about myself.
I agree with you. So maybe even Prasad or Datta is making presentation. Prasad can be a co-chair with ISRO scientist.
Exactly. I mean, this is what it
subject
should be.
domain expert. Domain expert to be the co-chair.
I only suggested this, that my being, because I'm not an AI expert in any sense. I can only
Correct,
talk
correct.
about in a very general way.
Absolutely. I totally agree. 100% agree.
So we can discuss and think about that co-chairship position as well.
Yeah. Anybody else? Datta Sab, you have. So your presentation is very, very important, because you will be in the first technical session. So as AK Singh mentioned, first give the capability of your the facility, something unique. So show one photograph and uniqueness of this facility, which is also being upgraded. And Chancellor himself has invested, taking a lot of interest. And so this is a new unique center that should come. Second thing is the expertise which you have over a period of time. You have been a global expert. So bring that dimension also in the next slide, 1 or 2 slides. Then third onwards, then the basket, and select 3 areas in which you have to go elaborate. This is the challenge. This is how I will use the AI tool, and this will be the outcome for ISRO. Like that, elaborate. That then the other thing can be discussed if they are interested beyond these 3 a little more. They will ask questions during discussion because fortunately they have increased the time. We have kept 1 hour for each session. They have increased to 1.5 hours. That means they are interested in discussing, understanding the depth of our competence, and then also discussing the collaborative research. So this is a very positive sign from their side. They have expanded the technical session, each session by half an hour. Okay, Datta sir,
Sir,
any response? Then we can move on to the Datta sir. Everything is okay?
I think everything is fine. Yeah.
Right. Perfect. Now, Shiva,
Sir,
Shifali,
uh,
can we move to the next?
yes, sir. Sir, we have been joined by
Shivani.
Dr. Sarath Raj from Dubai campus. He has requested if we
Sarath?
can have his presentation now because he need to attend one important meeting
Okay.
with Ministry
Okay.
of Education there, sir.
Right. Please go ahead, Sarath. Thanks for joining Amity Dubai.
Thank you,
Yeah,
sir. Thank
we
you
have
so much.
proposed his name for his virtual presence in the Data Analytics and Space Science and Technology, session 2.
Yeah, Datta, you want to say something? Yeah, please go ahead, Sarath.
Can you see my screen, sir?
Yeah, please.
Okay. So good afternoon, everyone. This is Sharath from Amity Dubai campus. I'll be presenting on the aspect of what our center is about and what are our skills and what we can collaborate with the ISRO in this aspect. So I just mentioned my qualification and research areas, and these are my collaborative entities by which I have received my achievements in terms of space age funding and other collaborative entities. So that is why I just mark it here. So this is just for the presentation purpose. I can speak on all these aspects, what are the things which we have been mentioned. But my primary intention is about how Amity Dubai can be harnessing the collaboration with ISRO. So basically, first I will start with the Martian studies, where we have conducted and completed the studies in terms of various research, including the prediction of dust storms, H plus ion concentration in the lower atmosphere of Mars, and diurnal variation of Mars, carbon depletion in the Mars, and diversification of energy sources in the Mars, and study of planum boreum ice column distribution. All these research has been completed and been published by our faculty and our students. And as I mentioned, these are the published data which is readily available, and you can look at this research where we can get harness the collaborative effort from ISRO. So this is about the Martian planum and ice column distribution. This is the auroral formation and the diurnal variation from the Mars atmosphere. And a similar way, another strategic area where we are strong is about on the remote sensing aspects. So when we talk about the remote sensing, we are more strong in the disaster management analysis, land surface temperature, vegetation, water, air quality, forest fire, land use map monitoring, and war crime investigation. So we have the satellite ground station in our university, and we use different types of software for doing different kinds of analysis for remote sensing purposes. And current research based on the Martian atmosphere, we are basically doing the Martian mineralogy analysis at the moment. And another one research which we are doing is on the shape memory alloys, how we can use the shape memory alloys for the rover wheels. That is one of the booming area where material science plays greater impact on the extraterrestrial environment, and almost all space agencies are currently doing this research on terms of extraterrestrial Martian rover vehicles. Similar way, we are doing also another interesting study on Martian agriculture, where we will be using Martian regolith and rock wool, where we will be putting the lights in terms of variation of the light spectrum, and we will analyze the study. This is what our phase 1 study. And in the phase 2 studies, which we are trying to have an emulation surface, that basically a Martian simulator will be created, and there we will be doing the research. That is what our phase 2 analysis, that is where we are into it. And in terms of possible collaborations with ISRO, I suggested 2 areas, which is one is about the satellite ground station, which is basically for amateur band frequency. And in case if we want to extend the frequency range, we can able to increase our antenna capacity, and we can move on to other bands of frequency where the satellites are sending the information. similar way, radio astronomy and the remote sensing. So these are the one area of possible collaboration with the AUDC campus. And moving on, the second one is the Martian studies, where I have highlighted in terms of Martian habitat studies, which includes Martian agriculture, as the phase 1 study where we will be using the Martian regolith, and hydroponic studies with the variation in the light spectrum. And secondly, we will be emulating the same studies with the help of a Martian simulator. And we are studying about the various Martian energy sources, because we are collaborating with the Mohammed bin Rashid Space Center for Mars 2117 program. So diversification of Martian energy sources is our primary study, and we are trying to identify different Martian energy sources to be utilized in the Martian habitat mission. So this is the possible collaboration with ISRO from AUDC campus from my perspective. And if you look at the ISRO website, and I've clearly taken the screenshots of ISRO website, which is clearly mentioned about the space science research mainly focus on the Mars orbit mission only. So Martian habitat has not been covered up in the ISRO studies, and this will be a great pitching point where we can get possible collaboration with ISRO. So this is from my side, sir, and I would like to open for discussions.
Now, Dr. Prasad, Prasad, unmute the mic. Your mic is muted.
Dr. Sharath, can you hear me?
Yes, sir. Well,
Yes.
sir.
There may be a small point. You are doing the Martian surface study, a Martian study, mention data available on the open source, because sometimes what happens, Emirates Sensor may not like to share the data immediately with ISRO. I do not know that. They may be sharing it.
No, we have the Science Data Center, which clearly
Simply
provides the
say,
data to everyone, sir. It's a
whatever
public
data
domain.
is available in the open,
It's a public domain, sir.
Public domain, we are ready to do the Martian study in this domain, what you are saying. Otherwise, it's good. Shape memory alloy is good. Some more people I will get you connected who are doing the work with it. Thank you, Sarji.
Thank you, Dr. A.K. Singh sir.
Sir, just I would like to submit, can there be any locational advantage which we can leverage? Because, it's a kind of a layman question. Because one is that the technical expertise and technical strength which we have, through which we would leverage. Now, because it's a unique facility by any private institution located abroad, right? So,
yes, sir.
And ISRO, and which is rare. So can we project in any way that locational advantage? Because I can't spell out, because I am not expert. I think Dr. Prasad or you,
Sir, you are very well
experts
correct.
can,
And being in the Middle Eastern region, I think for VHF and UHF frequency, we can able to collect any satellite data which are able to open us, and we can have a collaborative effort or MOU with ISRO, and then we can able to track the satellite and collect the data for checking whether the signal is strength and other aspects, sir. We can
and
able to
number
have that.
2, in the formal program, there is no of Dr. Sarath Raj. We have to see that he is given some slot, because this facility we need to project to ISRO there.
Sure, sir. I will add it on, sir.
Thank you. I think A.K. Singh, you brought out a very important issue. Thank you so much. That location advantage, because our Chancellor, Dr. Atul Chauhan ji himself has invested this ground station. It is his vision. So I saw his photograph also in that. So you can mention Chancellor inaugurated this. But more important is, one is your link with UAE Space Agency. And also you can expand on the power of your ground station. How
Sure,
many
sir.
satellites you are receiving the data, what is its computational capability, how it is being used, what is the volume of data you are getting. So the power of your ground station should be first highlighted. The second
noted,
is
sir.
why it is established in Dubai. And as he rightly said, the advantage, location, which will be helpful to ISRO, because they may say that why don't you give me this information, because you are here in this area where the RF and other signal is much higher. This is a great point which you brought. Please bring that also, the location advantage of our ground station in Amity, Dubai.
Or sir,
Third is,
they may like to augment that center through their resources for their use.
absolutely, that's a fantastic point. So, Sarath, इसको थोड़ा highlight करना है. Just highlight this aspect also. And then what you have done using the data from satellites, what type of outcome which the students have benefited or research has been done. So a few minutes on this you should spend so that it's a unique.
Sure, sir.
And your location advantage is also very great. Then you mentioned about MOU. Sudhirji, Shefali, Sudhirji just on his own mentioned that we have
Yes, sir.
removed MOU because we will sign it at a later date. This we will have to take some internal approvals. And so he himself on his own, he mentioned that since Sarath also mentioned, they are going to sign MOU with us. So
Great.
this is already, they themselves are very keen to have the MOU. And so, as you rightly mentioned, we'll do that. Then also, when you mentioned Martian studies, elaborate. You have only
Sure, sir.
given Martian agriculture, Martian habitability. These are just the mentions. But what you will do there? Habitability means how would you, so will you look at the materials which can be, or how will you transport the materials there to build the stations, International Space Station or the habitability in Mars? So you will have to give a little elaborate instead of just mentioning habitability work you will do. What is that you will do in that area? Similarly, Martian agriculture, will you simulate it here? Or will you do that? Also mention about Martian analog station, which we already have with our Amity Maharashtra is having at Ladakh. So when you are mentioning some of the agriculture work we can do here and can analogous to what you can do in Mars environment. So like this, you will have to elaborate on that mentions which you made so that then they will understand what exactly you will do in that area using your capability, ground station and Amity's expertise.
And sir,
Sure,
one
sir.
more thing, Dr. Sarath, in the meantime, can rather propose what can be done. And we all can, Google, because Dr. Prasad is there, he's an expert. Even he can suggest that if we can propose something to them, which even ISRO may not be thinking, I think loud.
Very good. Neeraj, anything else, Neeraj?
The only thing which I would like to re-emphasize, Sarath, that whatever we have done in the past with our ground station, what experiments that we have done, what studies we have conducted, if at all they are supported by the UAE space agencies or authorities, or there are some projects that you may have got it, how you have utilized that facilities and how you are utilizing that facility, that will give the ISRO a confidence that Amity is not just talking in thin air. They have already done it. They have a facility with them. There is a space facility available with them.
Sharath, good point, because you have relationship, already collaboration with European Space Agency. Just elaborate to all the people, European Agency,
And
NASA.
also, yeah,
Yes,
and
sir.
also, sir, Sharath has been given an online slot. Shefali, please correct. We have given him an online slot, and he will have to make a presentation, because his presentation is the most important presentation according to me, because he is the one, apart from Datta's presentation and Dr. Prasad and Shivani Verma's presentation, but this is a unique facility that we have, so we have to emphasize more and more on this.
Yeah, show that in
We'll
the
add,
program
sir.
also. Shefali, if we have
We will
not
add, sir.
included. So, Sharath, just expand briefly about your
Sure,
collaboration
sir.
with European Space Agency and NASA. You already have it.
I will collaborate. I will specify it and very clearly, sir, what are the
Mention
fundings
that.
which we have
Mention the
received from
benefit for
space
everyone.
agencies, and then we will talk on that, sir.
No, can you briefly mention to all of them just in
Yes,
2 minutes?
from UAE Space Agency, we have received a funding about 256,000 US dollars, and
Fantastic.
we are using that funding for our CubeSat trajectory analysis. And
Yes.
similar way, we are receiving the funding from DEWA, that is about 20,000 dirhams, which we are also using for unmanned aerial vehicles design and analysis, sir. So these are the two major fundings.
Very important, very useful funding that you have received.
You were
$256,000
not
is not a
highlighting
small
this.
sum.
You are not highlighting this.
Yeah,
you
sure.
have to highlight this. This is
Actually,
very
I highlighted
important.
in my achievements, but I didn't want to specify it only for that. That's why I
Because
just.
this is the global connectivity your center has. Not
Yes.
only with this European agency and NASA, also you are doing something with them.
We have collaborated with NASA and JAXA for the Kibo RPC programming challenge, and we were the winners, first runner-up for the NASA Kibo RPC programming challenge, sir.
Please show
Similarly,
this. Please show
You should-
this.
sir, I
you
have
should
mentioned in my achievements. I'll just share my screen.
No, in your presentation, make one achievement slide. This is your competence, no? This
Right.
is your strength. Bring your strength, display your strength.
Sure, sir. I will modify my presentation and I will send you.
And they will say you are working with NASA, you are working with European Agency, Space Agency, you are working with UAE Space Agency.
Absolutely.
Then your value goes, Amity value goes up.
Absolutely.
With
Good.
Roscosmos also we have collaborated, sir, for the World Skill Russia. I am the space system expert in the World Skill for Roscosmos.
All this
For
four
satellite engineering.
All this
Yes.
four, maybe in 2 slides, you can bring the 2 slides.
Yes, sir.
Good.
I will add on.
Now we can move on to the next presentation.
Sir,
I'm
an
taking
important, sorry, Dr. Sarath, please go ahead. Dr. Sarath, you want to speak
ask anything?
something? Yeah, sir, important information. Just now received call from Dr. Paul. He has mentioned that 18 participants from ISRO will be joining the whole program,
Very
and
good.
7 participants will going to present during the technical sessions.
Very
4
good.
will be presenting in artificial intelligence session, and
Right.
2 will be presenting in data analytics session, and 1 will
Very
going to present in astrobiology session.
Great. See, that is the interest they are taking.
Yes.
Like we are taking, they are taking a lot of interest. See, so many people coming. There's a large contingent coming from that shows how much importance, expectations, aspirations. I want to tell all of you, this you have to meet this aspiration. You should be the best, the number one in space research in the country. Every problem should come to Amity first before they give it to anybody. Great.
And he has also mentioned, Dr. Paul has also mentioned that no need to have chair or co-chair during the technical sessions. If you want, if Amity is interested, you can have the chair from Amity side, and they can navigate the whole program.
Very good.
And 11 participants out of 18 will be attending the whole technical sessions. They will be with us throughout the program, sir. So total 18 participants from ISRO, sir.
Now you can ask the names of the profile of the people also.
By today evening,
so
he will share all the details, sir. He has mentioned, sir. Yeah.
So Sudhir has taken quick action.
Yes, sir.
Shefali,
Very nice.
Sir.
Shefali, you are talking about call is
Just sir, अभी डॉक्टर सर डॉक्टर M.K. Paul है शायद इनका पूरा नाम सर. He is Associate Director, Capacity Building, Public Outreach, sir. Yes, sir.
Very good. So,
अभी उनका कॉल आया सर.
So now go ahead with Shefali, next one.
Yeah, next is Dr. Shivani Verma, sir. She will also, we have proposed her name in the application of artificial intelligence, session 1. Shivani ma'am, we would humbly request you may kindly upload your presentation. Then, sir, Dr. Sarika has requested, after Shivani Verma, we would request Dr. Sarika to be ready with the presentation. She also need to attend some important meetings. So after Shivani Verma, we will humbly request Dr. Sarika Jain, sir.
Right.
Yeah.
Shivani, please go ahead, Shivani.
Yes, sir. Good afternoon, sir. So I'm uploading my presentation.
Sarika, be ready with your presentation. Next will be yours.
Yes, sir. Yes, sir.
Yes, sir. Okay. Very good afternoon to all. I hope my presentation is visible to all.
Yes, please go ahead.
Okay, thank you. So these are the starting slides which tell about brief of my accomplishments and about my education and experience. I'll just skip through the slides. These are my research accomplishments about my projects. So finally, I'll start with the research work that has been done under the aegis of Amity Center for Space and Defense Exploration. I start with my TDF project, AI-based detection of a person based on physiological parameters, which has already been completed and handed over. Why this is important here? Because we have done a lot of work on pose estimation, which we will be proposing for Gaganyaan mission. As you can see in the slide, we have gone for occluded face detection and pose estimation for identification of a person. We have also worked a lot on pose estimation of unmanned aerial vehicles. This is of importance in space when we are discussing the docking capability of non-cooperative satellite objects. I'll come to the slide which discusses our ISRO project that has been awarded to us last year. This is a very important project that is a part of NISAR mission. NISAR mission is having L and S band synthetic aperture radar. So one of the prime objective of NISAR mission is space debris detection. But as the SAR platform is moving and the debris is also moving, so Doppler effect comes into picture. So we are exploring algorithms which will be mitigating the range walk and range correction aspects of Doppler effect. We have worked on a number of algorithms. One more year is left, and very soon we'll be coming out with an optimized algorithm for mitigating the Doppler effect. We are also working on cognitive health monitoring system for spacecraft and aircraft. This problem is very important when we talk about space science because we are going for deep space missions now. So ground communication becomes difficult. There's a lot of delay involved when ground operators have to contact the astronauts on board. So we are developing an onboard system which will be detecting the anomalies and recommending the corrective action as well. We have done a lot of work. This is one of the novel approaches that we have proposed. We are continuously getting time series data from spacecraft or aircraft. We propose converting the time series data into images and then work on them using convolutional neural networks. And GAF and MTF techniques have been proposed. These are our results that we have obtained. We have also worked on point, contextual, and collective anomaly detection. We have identified these anomalies in the spacecraft and aircraft data available online, and we have obtained these graphs which are highlighting the anomalies. We have also worked on Chandrayaan-2 data. We have developed a digital elevation model by going for the terrain analysis. The data was taken from the ISRO website. We have done all the data pre-processing. The results are available on the screen, starting from clipping of data to shading of the hills, and finally getting the texture analysis by which the digital elevation model can be clearly explained. Now we are going for economical space transportation. So minimum energy transfers are required when we want to change the orbits. That is a live space domain. Trajectory optimization of a satellite. We have very optimized trajectory of a satellite. We have worked a lot on image analysis, be it optical images or SAR images, and we have also worked on fusion. In the forthcoming slides, I'll be been done. We have worked on SAR images. One of the problems given to us by CARE Bangalore was detection of illegal ships, that is dark vessel detection. So we worked on SAR images, and the last picture on the bottom right corner shows the ships that have been detected. We have also worked on SAR images for detection of burnt area. This is the burnt area that is visible here. Further, we have worked on LiDAR image processing. We have used it for finding the safe landing zone on airports. We have worked on fusion concept as well. We have taken fusion of hyperspectral and LiDAR images, and as shown in the fused images or in the blended images, some of the features which were not very clear in hyperspectral or LiDAR image can clearly be observed in the fused image, thus increasing the certainty of object detection. We have also worked on fusion of optical and SAR images. So this is the optical image that we have taken. This is a SAR image we have taken. And this is the fused image where this bounding box shows the object which which was not very visible in the optical image, but after fusion, it becomes conspicuous. Depending on the work that we have already accomplished, we are working on some of the problems that are live problems in space domain. Like I said, we have done a lot of work on pose estimation, maybe for person recognition or for UAV pose estimation. We are doing some work on vision-based pose estimation for non-corporate docking inspection. We are also working on Gaganaut intelligent health monitoring system. We want posture identification to be here, which would help us in increasing the certainty of our result. Data set for pose estimation is not readily available. This was also pointed out by AK Singh sir last time. So we have worked on that aspect. Yes, open source data is not available, but we have worked out that yes, we can make our own data set. Every astronaut needs to go for 1 hour exercise regime in a day. So at that moment, we can capture the points which can be considered as our criteria for determining his health. Next work under progress, because we have worked a lot on SAR images. So we have also submitted a proposal on it. We are working on compressive sensing techniques for SAR image reconstruction. And these are the novel techniques that we have come out. Ramanujan, one of the algorithms, I'm sorry. Yeah, these are the novel algorithms that we have come out. We are, my PhD is on FPGA implementation of turbo codes. So we have expertise in FPGA implementation. So we can also work on this image stabilization software, which is already available with an ISRO observatory in Udaipur. They are looking for FPGA implementation. So we are also working on it. Next, we are also working on joint probabilistic data association and multiple hypothesis testing of data association, because nowadays it is not just one target we are focusing on. We are having a lot of space debris, we are having a lot of resident space objects which are interfering or overlapping with each other. So we have worked on algorithms which can detect the object very precisely in this multi-object environment. Then very important aspect of space science, we are going for estimation of radar cross-section of space debris. We are also working on signal processing framework for debris detection using the signals from radar. Like I said, we are working on Gaganyaan mission. We are working on cognitive design of spacecraft. Anomaly detection is one of the part of cognitive design of a spacecraft. So we are maintaining a database which will be helping us in anomaly detection. Based on that database, we can go for onboard decision support system. These are the potential areas where we are looking for collaboration with ISRO. Like I said, we want to go for FPGA implementation, Gaganyaan mission. We want to go for it because we have done a lot of work on number of its aspects. Space situational awareness, space debris detection, its radar cross section are our field. We can definitely collaborate on it. We also want to collaborate as an industry, because we are having Amity startup. So there are schemes with ISRO, as Mr. Pradeep, who is head of ISRAC, he conveyed to us, we can collaborate on that front as well. We are also working on developing an Amity Center of Excellence for Space Radar Signal Processing that was proposed to us again by head of ISRAC. So some points I have not included in my presentation because there was a mail that overlapping should not be there. But yes, we are having a lot of work in agriculture domain. If you look at AI, we are having a ground station, NOAA ground station in our institute. We are also working on CubeSats, that is missing in my PPT. We are also having a telescope, a very good resolution telescope, the data of which can be used for analysis. Plus, we have done a lot of work on super resolution of images. Thank you, sir. That's my presentation.
Thank you. Thank you. Professor Prasad, anything you want to supplement? You stop sharing, Shivani, stop sharing.
Yes, sir. Yeah.
Prasad, anything else you want to add?
Sir, we will add a couple of slides couple of more slides in our presentation of the work which already has been done. That I will add it up. I did not add it because some I have already, Madam Sarika is working with us. So we said that overlapping should not be there.
Right, very good. Dr. Eki, your comments, please.
I think, sir, she has made a wonderful presentation, and I think they are the backbone of space research in Amity.
Yes.
Shivani and Prasad, there is no doubt about it. And I have one or two submissions to Shivani. Shivani, you just took us through that this work is in progress. This work is in progress. Great. I think when at one point of time you said you are working for the Gaganyaan. Then in your last slide you say you would like to work collaborate in the Gaganyaan. Since you have already submitted the proposal, you can be more specific. That this work I have done, I would like to extend that. Right there you can be more specific. One, the debris detection, I think overlap. I think you have already seized of this issue that you will take care. And in your presentation is going to be the only presentation where we would be saying that already we have strong collaboration with you.
Yeah.
Already we have a collaboration.
Yeah.
And and that is the strength. Now you please, in one or two highlights, you just say what afresh you want to propose or what you want to extend, clearly bringing out. That is my submission.
Thank you, Dr. A.K. Singh. Dr. Neeraj Sharma ji.
नो सर, आई थिंक प्रसाद साहब के लिए तो सूरज को दीपक दिखलाना होगा. मेरे पास कोई कमेंट्स नहीं.
Thank you, Dr. Khatri.
Next, sir, I think presentation was very well made and very specific. So outcomes are, I think, defined कि हम क्या उनसे कर सकते हैं already. And जैसे अभी सिंह साहब ने कहा कि this is, I think, the first, I think, main presentation जहाँ हम show कर पाएंगे already some outcome coming out it. So
Very
this is
good,
going to be
very
an interesting presentation for them also.
I will just sum up your little suggestions for your consideration. First thing is you bring out Amity has got a separate Institute of Space Science and Technology. Amity Institute of Space Science and Technology. From very beginning, we have established an institute which shows the founders' commitment to the space research in the country, in Amity. Then say how many students would have passed out? The number of your HR, so academic achievements, so many people, we are running programs. So then I want to also give them, there is a separate institute in Amity which deals with space science and technology. And these are the achievements so far from this institute on academic research, first part. The second part will be, we are already working with you. We have an ongoing ISRO projects. These are the sanctioned, because I have also sent to founder president the sanctioned project, which is ongoing right now. So bring that project. We are already working. What you have completed with ISRO, what you are doing ongoing, there is a project which you are doing on the debris. So that also bring this a sanctioned project. 1 year we have completed, one more year it is there. Bring that. Then second thing is we are already dialoguing with ISRO on these projects. That means you are already talking to, if you know the person's name, you are there, your counterpart there in ISRO, with whom you are dialoguing, mention that they may be there in the meeting also. So you mentioned that we are dialoguing with so and so, so and so on this ongoing projects. Bring the gist of those projects. Now, having done this, now we want to do this. Then expand on what is your aspiration for the canvas, and maybe in the immediate priority, 1, 2 area deep, go into that this is what we can do for Gaganyaan mission, for health monitoring of the astronauts, Gaganauts, and also because Gaganyaan is coming. So how you can help them by using the AI software and the posture, the training which you showed, and also the health of the individual by looking at their facial expressions and so on, using the database. So like that, if you can bring two areas in which you want to further expand, the already dialogues which you are having, already the sanctioned project you are executing, this is what we like to do. Then in the discussion, you can bring out. I would request Prasad, you can make initially some opening remarks and then hand it over to Shivani, so that you have been interacting with ISRO. Many people will know you in ISRO. That is why this can be the format. Okay, thank you. Thank you, Prasad. And Shani, wonderful presentation as usual. You communicate very well. Compliments to you. Now we can move on to Sarika. Sarika, please go ahead.
Yes, sir.
Show it on slideshow, full screen. Yes.
So good
Go
afternoon,
ahead.
everyone. I am Sarika Jain and professor in Amity Institute of Information Technology. This is my brief profile. I have done PhD in mathematics with the application area of computer science, and I'm just skipping this slide. About the research accomplishments, we have majorly dealt with the satellite data. So this we have developed automatic detection of weapons, which is used in military based using deep learning. It utilizes multi-level CNN architecture with 3 layers of CNN to classify 3 kinds of visual images for detection of weapons in an image. This proposed system achieves an accuracy of 97.7% for the image classification, and this experiment was performed on the dataset of 2,700 satellite images using TensorFlow and Keras. So this is our in-house system build. Other important project which we have done, and we have published a research paper on this too. We have defined and developed a model to deliver 5-fold improvement in training time and rapid prediction of 20 classes. These classes could be agricultural, beach, buildings, chaparral, dense residential area, forest, freeway, golf course, harbor, intersection, any other like mobile home park, overpass, parking, runways, sparse residential, etc. So which is necessary for real-time application. This data we have gathered through satellite imaging, and this is temporal-based data which we use to collect time to time. So this proposed multi-level convolution neural network, this achieves an accuracy of 98.14% on the training dataset, wherein the training dataset comprised of 7,000 satellite images within the 350 images in each class. So this is again our in-house developed project, which we have worked upon. Apart from this, we have completed one DRDO ARDB sponsored research project, which is on design of all-weather foreign object detection system on runways using visual and millimeter wave imaging with the following objectives. What we have done in this, like the runway is prone to accidents where we could find the small objects like the nuts, bolts, keyrings, and very small charger they used to find on the runways. And generally, it is manually checked whether these kind of objects are being present on the runway or not. So for this system, we have made an automated system. For this, we have integration of millimeter wave radar system with the visual band camera using with sensor fusion. And with this, we have detected the foreign objects on the runways and did the customizable calibration for varying detection thresholds and requirements. So the overall system design for this, we have just integrate all 3 type of sensors. One is visual sensor, thermal sensor, as well as the radar. So the radar could be our strength here because we have worked on the radar data, and this is 77 gigahertz, which is generally not available. So we have just calibrated all the 3 sensors into a single sensor, and this is optical, thermal, and millimeter wave sensor. We have integrated all these sensors to apply the object detection algorithm. For all the different sensors, we have applied different type of algorithm, like a simple background subtraction algorithm works for optical sensor. For thermal sensors, we have applied other kind of algorithms which works finely in thermal sensors, and millimeter wave, which we use to collect the radar data. And with this, because we have find out the exact range, where is the exact element is present on the runway, and we used to give the range. So in the final system, we have detected the object and range. We have displayed the FOD, and like this will be the final outcome, and the notification will go to the user. There is an FOD present on the runway. So this proposal, this was sponsored by ARDB, and we have received the grant of 22 lakhs for this project. And our next idea was to continue this experience of working on the radar system. So our aim is to develop a system with the ability to predict lightning, gale probabilistically on a 1 to 2 kilometer resolution grid with a temporal resolution of 15 minutes and lead times up to 60 minutes. The reason is because whenever a plane just lands or take off, so there could be a huge possibility, like within the just last minute, there could be the possibility of lightning and probabilistic gale. And the flights, they got delayed just at the last minute. So to avoid these kinds of problems, we want to develop this system. And it could be AI ML based prediction of thunderstorm and gale force wind over an airfield. The proposed concept could be a data-driven technique, because we are working in data analytics. So it could be a purely data-driven technique could be employed based on, for this, we may be needing time series radar data or the satellite image data archives to extrapolate using two main procedures, namely diffusive process in Fourier space and deep learning networks. Other networks like UNet, convolution LSTM GN can be used. However, a more realistic approach could be based on trajectory-gated recurrent UNICEF. Our approach could be the combination of CNN and LSTM to create a spatial temporal deep learning architecture. The input will be the radar images. It could be of the resolution 128 cross 128 or 128 cross 256. So this could be the extension of our previous project. And in this, we can use the satellite imaging data archives. How this expertise could further be utilized by the ISRO, we have the satellite imaging, weather data, and the space data like Aditya L1. So the proposed proposals, this could be first, which we have discussed, generation. Whenever a satellite imaging, a standard image size, the 1 pixel is of the size 10 meter cross 10 meter. Because this problem we also feel in our ongoing research work, because the quality of the images is very poor and it is quite difficult to recognize the objects out of them. So we want to increase the resolution of the images, although there could be methods like interpolation, but we want to make it automative, and we wanted to use the latest network, which is generative adversarial network. In this, we may be needing satellite imaging. And like for an example, moon images, it could help in understanding image surface better. So if we have the moon image and if we could increase the resolution of it, then we can analyze the image of the moon better. We are working on spatial temporal GAN to have time domain high resolution images like SAR images. About the GAN network, it is consisting of two parallel networks, whereas one we are having real image samples, and the other means instead of generating the new image with interpolation, we can generate the other image with the simple random seed generator. So these could be the fake generator, but of course this will be as much possible as much near possible to the real image. So if the discriminator is not able to differentiate between the fake image, although the fake image here is the high resolution image. So if the discriminator is not able to discriminate between the fake and the real image, then we can just use it for our purpose. So it could be just include all the steps of our machine learning process, starting from gathering data, preparing that data means cleaning and everything, choosing a right model where we can use the GAN network, and then training that model, evaluation of that model. With the process, with the time, over time, we will be doing the hyperparameter tuning, and in the last, we will be doing the predictions. Other important project which we have discussed is space radar data analysis. Generally in the ISRO, the radar data being gathered by ISTRAC. So we can do the analysis of the same for environment purposes and the weather prediction, like wind movement. What is the direction of wind, whether it is towards the land mass or in some other direction, or how the wind temperature, precipitation, etc. is varying, so that we can predict the rainfall and the dry area based on weather images. So the thing is, all our projects are basically interrelated because I wanted to make use of our expertise in radar, how the data given by the radar could be analyzed for further research and analysis. So this is prediction of weather at IAF landing zone. Another, which may be duplicacy, but I, along with Prasad sir, we will be working on it, whether we should include this part or not. This is debris data analysis. In this, we can design a fragment model and compute the number of fragments. Then we may have to compute conjunction of two orbiting bodies using TLE. TLE is basically a two-line element. It's a process and a standard format which is used to describe the orbit of a satellite. So the set of data produced by this TLE, it consists of satellite position, its velocity, and other important data which may be related to the orbit at a particular epoch or time. So we may try to model the fragments in which a satellite will break in case it gets impacted by some other satellite. So once we know what is the fragment size and number, it is directly related to the debris it will produce, because if we have the accountability about the fragments, if we can give them the size and the number, then we can keep an account like what will be its behavior, what will be its curve to follow, and then in that case we can avoid the further collision. We can do the risk assessment, and we can also do the mitigation part. So for this, we can find out the trajectory of those broken fragments. So this could be another important project. However, this project could be different different could be because there is so much analysis is being done in debris data analysis, but the way we are doing it is different. We are just finding out the trajectory of this broken fragments, and the others may be working on some other aspects of the debris. And the last one is exoplanet data detection. So as we all know, there are a large number of planets which are Earth-like, and the planetary observational data is made public by ESA or the NASA. So we have developed an artificial intelligence program to analyze the data and predict that present planet is exoplanet or not, and we are just trying to fine-tuning it. Other novel ideas or proposal, which if you say we could elaborate. Generally, the images, satellite images.
Selvamurthy sir.
Yeah.
Yes.
I think this is too long a presentation. Probably we need to curtail it to a limited.
Sir, I just need one more minute.
No, I think you have already spoken for 20 minutes. Probably,
no,
I think.
I don't.
Okay, no,
much
let's
time you will
listen
not
for
get.
another minute, one more minute, and then we'll give a suggestion. Oh, please
Also,
go
I
on.
think I also suggest those who are in the Noida campus, please come to us. Please come here to make your presentations. Don't be online. We will request all the presenters from Noida campus. Correct.
Okay.
So you please
Right.
come here.
Good.
Come with your presentation. Next time, the next mock presentation, Shefali will tell. I think is on 8 or something. Then please, we request you to come here and make presentation. Thank you.
Okay, so the further
Sir, I will go through it, sir. Madam Sarika, 1 minute.
Yes.
Sir, I will go through our presentation and make it better.
First, let her complete it. Let her, Sarika, please complete it. Take your time. Complete it.
Yes, sir.
Because
So the other ideas could be like the satellite images. They are not variant for the scale, invariant with scaling, translation, and rotation. So we could design an algorithm where we can design we can do the object detection and make the images invariant with respect to scaling, translation, and rotation. We could also develop deep learning framework for auto quality certification of all IRS optical satellite images, and AI-based technique for the retrieval of atmospheric motion winds. Like what is the quality of this image? We can give an index to the image. And this liquid neural network is the latest approach in deep learning where we can it is a kind of adaptive neural network where the set could be the optical images or the radar images, and it depends upon the atmospheric condition. If the image obtained is not good, so we can make our neural network adaptive so that it works well with the time. So these are some new ideas.
Expand on this, Sarika.
Yes,
Yeah,
sir.
can you just expand on this liquid neural network? I want to learn. This is something new.
Yes, sir. This is actually a new type of deep learning approach which has just come up. So this is kind of adaptive neural network. So as per let us say if I have taken an image and it is not of that quality which we wanted, so we can adapt. We can just reset our deep learning approach or neural network so that the quality of my image is being increased. So this neural network is kind of adaptive, you can see. Means
Good,
it
good.
is adaptive as per the scenario.
Right, right. Very good, very good. Sarika, very good.
So thank you, sir. This was all from my side.
Now, Prasad first, and then AK Singh, and then Neeraj.
Sir,
Yes, sir, I
if
will.
you, sir, if you allow me, I will take only half a minute. There is a message from Founder President, sir. Silvamurthy, sir.
Yes, yes, please go ahead.
Yeah, sir. Sir has sent a message just this moment at 15:50 hours to give the very important information received from Dr. Paul from ISRO, and Dr. Silvamurthy ji rightly commented that this shows their great interest for this workshop. Please send me the names as soon as you receive from Dr. Paul. Then my work would start knowing deeply about these scientists. Please read out this message to all who are attending physically and online. Sir, please check your email. I have just sent the
I
email
have seen
received
that.
from Dr. Paul, sir.
Yeah, thank you. Founder President, thank you so much. Founder President is observing all your
Yes, sir.
presentation. So he will also give his advice, guidance subsequently, and we will take it and convey it to you. And see the commitment, Founder President, finding time to see your presentations. This is Amity. This is Amity's culture for research, innovation, and the passion. So thank you, Founder President, for this message, and we will certainly communicate immediately to as soon as we receive the message. Now, we are also joined by Dr. Santosh, the Vice Chancellor. Now, before that, about this, Prasad, any comment on Sarika Jain? Santosh, we'll come to you immediately after the discussion now. No?
Sure, sir. Thanks.
Prasad, tell me. Anything on Sarika, or you will discuss separately?
I will talk to her, sir, make it little more compact so that it is better.
Very good. Dr. AK Singh?
I think Dr. Prasad and Sarika would be able to comment. Sarika, you had been saying, the super resolution. And
Yes.
then you also in the second last slide mentioned upscaling.
Yeah, what I mentioned in the second
Scaling of the images, upscaling.
No, sir, that not upscaling. That scaling is like when we scale, means that is not related to resolution. Scaling means
Sizing, increasing the size.
increasing the size, increasing
That is
the
upscaling. That is upscaling.
Right, right.
When you increase the
But
size,
that is
that
not
is upscaling.
related to resolution.
So my submission is, you would pardon me if I'm wrong. If you really see, because last time when you said, I just tried to understand. Small applications are already available on net where you can improve the resolution of your images. So my worry is, now we have to spell out in what way you differentiate yourself to help ISRO in upscaling and super resolution of the images. That is my submission.
Sir, the small algorithms which are present here, that is not for the satellite images. We have the visual images. For that, we could increase the resolution, or we can make it invariant with respect to scaling, rotation, etc. But this work is not, or these small algorithms and applications are not available for the satellite imaging.
Yes.
Okay. Good. Neeraj?
I believe the recipient ministry is MOES. That is number one. Whom should we talk to? I mean, the data may be available from ISRO or some other source, Bhuvan or whatever. The other thing is that there are applications now available for these kinds of things which you are proposing. Please correct me if I am wrong, but there is a lot of applications available online, offline. Everything is there. What newness? What is the innovative thing that you are bringing up? So if you can bring that into it, if you can bring that innovative ideas into it, and next time I would request you to please come, physically to our seminar hall or wherever Shefali is going to organize, so that we can face to face is better to understand.
Yeah,
right?
of course.
Thank you.
Khatri, anything you want to say?
Yes, sir. Dr. Sarika, your presentation slides you can reduce because it is very long and time consuming. So you
I
have to.
don't think, sir, have I taken 20 minutes? I don't think.
No, it's not about 20. I had not mentioned 20 minutes. I had said very long because we will not get that much time individually.
No, I'll cut it short.
Yeah,
Okay,
so
okay.
that was my main observation.
I will get
Okay,
it done, Dr. Sarika
Right.
madam.
Now,
I will get
now
it
my
done.
suggestion. Now my suggestion. Sarika, and like what we have as AI Center of Excellence, you have created a data science center in Amity because
Yes.
this is going to be a data analytics session.
Yes, sir.
Please bring this Amity Institute in the Information Technology, Amity Institute of Information Technology. We have established a data science center.
Okay,
And this data science center, you give the photograph of all the configurations of your servers and the network which you have in which block?
I
Which
block.
block?
In
I
I block,
block.
we have servers.
I block. I have visited your center. So this photograph should come first in
Right, sir.
Amity as a data science center.
Right, sir.
Then what all you have done in Amity Data Science Center, what you have done, please bring this. These are the highlights of what we have done so far in. Then you come to DRDO project of detecting the foreign object on the runway using this multi-sensor fusion of millimetric wave, optical sensing, and so you bring that data fusion capability which you have. And that is important because sensor fusion, there are three types of sensors, and the data which comes out, you are able to fuse it to get a knowledge out of it. This is required for ISRO. So, we have to build story like this. Then after this, you mentioned two things. I was fascinated by. One is prediction of thunderstorm, gale, and cloudburst. Suppose during a mission, which they are going to launch. These are all predictions are very important, not only weather predictions, lightning. So you say that I can guide and predict forecast using these parameters which you get from the various data using AI platform and the data analytics. Then even whether the Gaganauts, when they return back, where will they land? They can even change the trajectory. So many things it has application. So please bring this AI ML based prediction of these extreme weather conditions, which will be useful for space launch, space missions. So that you have to bring everywhere space application. So please bring that. Okay, then you look at the liquid neural network. This is something, a new concept which is coming for enhancing images, whether it is how new it is, and then what is that it can help in analyzing the resolution of the data which is coming up, whether it is image or it is signal processing, wherever it can be applied. So select 2-3 areas out of the basket. This is where I can contribute in space mission. So this is how you build the story and finish it in 15 minutes, maximum 10 to 12 minutes. So that it will be finished in 15 minutes. You can do that. You can optimize this. This is how you should organize your presentation.
Right.
Okay. Very nice.
Thank you.
Now, let's listen to our Vice Chancellor. He has also come out from the meeting, students' meeting. He will give a glimpse because his field itself is astrobiology. When he was in NASA, I want to tell everyone, Santosh ji worked in NASA. Can you just briefly tell Vice Chancellor sir your NASA experience where you worked?
Sir, yes, sir. Sir, first of all, we had a collaboration with NASA. So while I was in the US, we had a collaboration with NASA on a project, which is to study how our cells will behave if it is on the flight. And we had a total isolated module, which is named NASA. And also we have sent 2 times cells, progenitor stem cells, to the space using the SpaceX CRS-11 module. And we got back those cells and we did a total transcriptome analysis to study, and we have identified a quite a wired network about individual progenitor stem cells. As you know, that stem cells are the major cells that are very important for propagation of further cells. With regard to the work that currently we are
What did you
involved.
find? What did you find in this, the
Sir,
behavior of the stem cell in low gravity, microgravity?
that is a very big this thing, but to put it in a single sentence, I would say that progenitor stem cells proliferated very, very well. And also, we could see more of unique variations of single stemming. It means that the unique cells have come out during zero gravity, and we are simulating that here in Amity University, Mumbai Center for Excellence in Astrobiology, and we are now currently collaborating with the Bangalore Center on Human Spaceflight Center. This is one thing. The other thing is, as you know, that the Center for Astrobiology here is involved with the analog workstation. We have been successful enough to complete 2 expeditions to Leh and Ladakh, where we have Amity analog station right now there. But at the same time, we wanted to perpetuate that, and we wanted to bring in people to go there. So this is the third time in a year, in a row of 3 years, that we are bringing that in the month of July. And that is being approved by Honorable Chancellor. So the total number of people who have been totally earmarked would be 30, and we have a lot of calls on that. We have 4 of our collaborators from the Space Research Center Australia and World Space Center New Zealand to be part of that. And we do also collaborate with the Poland Space Research Center, where one of our student is now planning for a training for an astronaut. So these are the major things that we are currently involved. We'll be able to give I'll be able to give a greater this thing later on.
Okay, very good. So, if possible, we'll talk to Chancellor Sir that, since you have worked with NASA and also you have actually done astrobiology experiment there when you were there in US. So whether you will be able to join subject to your other commitments and all. So we will take the advice and guidance from your Chancellor. Otherwise, your people, you can groom them in such a way that they make the Selva Kumar, whom you like to send along with you.
Selva Kumar will be the person, because the other people are not right now there in the campus. And Selva Kumar will come on the 13th evening. As you know that Maharashtra elections are on 13th. 100 and out of 172 faculties, 153 faculties have been deployed there. So, so now today and tomorrow they are on training at Mantralaya. So that's why
a huge number.
Yes, yeah.
Huge number.
Because we did not in Maharashtra it is a very vast number, and inclusive of the OAs and peons we are also bringing in. So that is why.
But we would like to see the presentation earlier, Santoshji, if you can get the presentations done so that we can also give input. Astrobiology presentation.
My presentation you're talking about?
Yeah, your presentation.
Okay.
Your presentation means including Amity University, Mumbai. What I am talking about, Amity University, Mumbai.
Right, sir. Right. So, so how many people are coming there? I do not know. What is your sequence in which you are bringing in people
that
there?
Is yet to be finalized with founder
because
president.
as you know that we have a separate center for excellence, and also we wanted to be a part of it. But you know that when you came here for the convocation, when we spoke with Somnath ji, we wanted to do this here in Mumbai, but since you suggested Bangalore, and Asim ji also suggested that to be in Bangalore for a PR thing, we did that. So no, we love to be a part of it.
Certainly, you will be a part of it. Whether you will be coming in person, the chancellor has to take a decision on that. We will.
I'll talk to him.
You talk to him, and I will also, after you speak to him, I'll also give my recommendations.
Sure. Right.
Thank you.
Thank you.
Now we move on to the next one, Shifali. I think DC will.
Rika Sharma is left, no?
Sir, Dr. Gagandeep also. Sir, Silvamurthy sir and Singh sir, Dr. Paul mentioned in astrobiology, there will be only one scientist from ISRO who will be presenting. So if you agree, and if Santosh sir also agree, sir, we should have maximum participation. Singh sir, as we discussed, sir, from Amity side in astrobiology, because this is the gap area wherein we can fill.
Absolutely.
Sir.
They will be interested also.
No,
Yes,
sir.
sir.
Dr. Silmurthy, sir. What I was thinking, if it works, we can request Shivani to shift to astrobiology, highlighting that, the AI in expression and all, studying the expressions, facial expressions through AI to judge the health of the Gagan
Good
knot.
idea. Good idea. We can bring her also in this session, and she can talk about the health monitoring of Gagan knots using the vital health signing, heart rate and EEG and
because
oxygen.
she can link that because that it emanates from earlier successfully completed project of DRDO, that competition where detection of the differentiating between friend and foe.
Yeah.
So
Very good. So
Sir,
we can have Shivani, you got the idea, no? Prasad, one presentation is the first session, and even in this astrobiology, the health monitoring of the Indian astronauts, Gagannauts, with a proposal which you have seen given to me, I have seen it also, and so we can present it in that also. So she can come in both the sessions.
Yeah, Shivani can.
I will do that. I will.
Yeah.
And all this, all this finally, founder president, we will take his advice and decision from him. But these are all suggestions we will submit to him after the deliberations.
Right.
So, sir, if I'm getting it correct, so now, are you allocating any part to us, or what is the current status?
Certainly. See, you have to go ahead with the astrobiology is your domain. The key area, astrobiology means it is Amity University, Mumbai, currently the nodal center. So you will have to make the presentations in such a way, what all you have done and what you have achieved. And so far, what Amity University, Mumbai has done in astrobiology, not only the Mars analog station, but also you have the callus of the plant, bacteria, all that what you have tried to do. And you are already discussing with them. So all that can come, what is under discussion in astrobiology with them also. Then what unique things you want to do. In addition, we will supplement after your presentations, then the health monitoring of the Gagannauts, she will include for about 5 minutes.
Yeah, because I just wanted to convey, sir, that now currently our Center for Astrobiology is the nodal center, official nodal center for it. So I just wanted to make it
you will be the key player. You will be the key player, and the anchor for astrobiology is your campus.
Sure, right.
Okay. Now we move on to Rika or Gagandeep, whomsoever.
Sir, we'll start. Sir, we'll have the presentation of Dr. Gagandeep from Haryana campus. She will going to present if everything goes well and founder approve. Then she will be presenting in data analytics part. Dr. Gagandeep, we would humbly request, please upload your presentation.
Yes, ma'am. I am uploading.
All the best, Gagan.
Thank you, sir. Please confirm, is it visible?
Yes, please go ahead.
Okay. So good afternoon to one and all present here. Myself, Dr. Gagandeep Kaur. I am working as an assistant professor at Amity School of Applied Sciences, Haryana, Amity University, Haryana. So moving next, I am just going to present my topic on fuzzy decision-making algorithms and techniques. This is a brief introduction about my research statistics, which I'm skipping for now. So my work, the first area on which I would like to throw a light for the possible collaboration is the quantification of the uncertainties. So for this, suppose we are obtaining some data from the satellites or from the ISRO research centers, then we will be processing the data. Now, the work from where my work can begin is when there will be the possible uncertain data. So the obtained data may be uncertain in nature. That uncertainty may be due to the noise, maybe uncertainty propagation, maybe the hardware or software failures, or it may also be the knowledge based uncertainty, because we never know what the future is, what the future is having. So for looking at the future things, the techniques on which we work on are the probabilistic techniques, that in which we process the uncertain data. Now, possibly we do it by using two things. One is using the ideal determination and calculating the deviations from the ideals. And the second is we do it using the aggregation techniques by using different aggregation operators that are there in mathematics. So we can use either these two approaches separately, that is one for the ideal determination and one for the aggregation using the aggregation operators, or we can make advanced decision making algorithms based on the blend of both ideal determination and the aggregation operators. Now, the possible novelty that we can offer to ISRO based on this problem is, it can be into the multiple criteria decision making, where we can help them into the component selection. We can gap the bridge between we can bridge the gap between the lost or the missed data. So if the sensor, let's say the sensor has stopped working, or let's say if the information is not completely getting transmitted to us, we can bridge the gap using the mathematical models. And we can also make the consensus building, because what I have seen into the ISRO research basket is that they will be aggregating the information that they will be getting from the gagnauts. So considering the opinion of all the gagnauts altogether will be the prime motive also into the consensus building model for the decision making that we will be taking into consideration. Now, in this, the novelty that we will be offering will be that we will be offering them the refusal consideration also. Let's say if any gagnaut has refused to provide answer to a certain a question that we are looking for, looking the answer from them. Let's say due to any kind of thing, maybe he has missed it, maybe his devices were not working. So we can also consider the refusal aspect into the decision making algorithm using the in the model of uncertainty quantification. Next is as I have next domain that I can offer to ISRO is the cryptography. So in this, I will be working on proposing strong cryptic models for secure information transformation, and we will be capable of offering a wide variability in the single cryptic model. So let us say that, some alpha, this is just a simple representation of that. Obviously, in reality, based on some advanced mathematical functions, it will be more complex than this diagram depiction. So suppose that I am having a function fx that has been plotted onto the two-dimensional space like this. Obviously, we will be working into the multi-dimensional space, but in this presentation, for the better understanding, I have just projected it for the two-dimensional space. Now, suppose that any function is being represented onto the two-dimensional plane like this. Now, the novelty that we will be offering to ISRO is that we will be making the parameter-dependent functions. So, how it will help that by changing just a single parameter into the model, we will be deviating the entire cryptic model to the new set. Now, this will be what? This will be a kind of, this will help us in keeping an eye on to any kind of fraudulent activities that may be happening with us regarding the system security. That if we at any instance of time, if authorized sources that we are not that we do not want to offer the information to, then we can change just a simple parameter p, and the whole information of the cryptic model will change. So next is that next thing is on the basis of the mathematical functions in image processing. So how we can be looking at it? In this, we will be applying or making a new mathematical functions for image or video processing. Into this, suppose these are my picture frames, let's say P1, P2, P3, and so on. So these are the picture frames. If I am applying a function, so we are in our research, we have conducted several idempotent functions in which suppose the same frame is getting input, and if there become any kind of sensitivity in a single frame, let's say if a single frame gets changed, then that single frame will be reflected into the output very clearly. So even if in the video we are having a change just for a fraction of second, we will be able to process it, we will be able to detect it, and we will be sure that we are not missing out onto any kind of fluctuations in the data. So this thing can be used into the obstacle detection, in the path planning, that if we are having some images that of the obstacles, possible obstacles from the satellites, then they will be obviously acting as this changed frame in which that obstacle will be detected, and our mathematical functions will be giving us the changed output, due to which we will be understanding that yes, here this is the area on which we need to pay attention on. In this, we can also do the sensor signal analysis from the gaganauts, and we can also do the orbit tracing of satellites. I have not given all the mathematical formulations over here because obviously we were having the time constraint. So I have given the brief output of the principle on which the whole model will be working. Now, mapping it with the ISRO Respond basket, what I have seen that they need the possible collaboration in automatic path planning, in which we can develop algorithms based on the path planning obstacle detection, as I have expressed in my previous slide. We can also collaborate with them in the area of image processing by clearing the noise, differentiating between the multiple similar appearing satellite images, as this area has been discussed by many of my esteemed colleagues as well. Next is data processing and the pre-processing of data. Obviously, the data generated by satellites is a very big amount of data. We can contribute by analyzing the signals, by making the new customized model for processing the algorithms. Like name a problem and we will be having a customized algorithm for them based on the parameter differentiation. And we can help them in cryptography by designing strong cryptic models based on complex mathematical functions. We can help them in pattern recognition and medical diagnosis by analyzing the health reports and by health monitoring of the crew members, that is Gaganauts in the case of the possible mission, that is the Gaganyaan. So with this, I end up my presentation. I have tried to make it very short and crisp. Obviously, on your valued suggestions, I will be increasing the slide counts. Thank you.
Thank you, Gandhi. Very good, very good. Now, Professor Prasad, MS Prasad. Just unmute the mic.
Sir, I am here. Dr. Gagandeep, can you hear me?
Yes, sir.
Yes.
You see, you are talking about fuzzy decision making and other aspects.
Yes,
lot
sir.
of things in ISRO, see the data comes raw data, nobody can make anything out of that.
Yes, sir.
Even if you go to RSA or ISRO. So a lot of these, solutions are already adapted. What we will take your help is that suppose you are talking about missing data, like you are doing a mathematical function on number of images. What we generally do is sometimes a chunk of data gets missing. So like Dr. Shivani said, Ramanujan, transformation, she has implied there. So that type of thing, we can take your help. That will help a lot in doing that. Most of the time, we do this. And I saw your fuzzy this thing. You worked under Shankar Pal or something?
No, sir.
No? Because Sankarpal is supposed to be the fuzzy master.
Okay, sir, I have done my PhD under the supervision of Dr. Harish Garg from Thapar Institute.
Okay, very good. Doctor, thank you, Prasad. You can interact with him. Gagan, Gagandeep, please interact with him.
Sir.
Yeah, Dr. Datta, please.
No, Professor Prasad says Shankar Pal. He is the biggest living legend of all kind of, data mining and anything, He's I know him personally.
So please, Gagandeep, look at his work also. Huh?
Yes, sir, definitely.
And so you should be thorough with that. And also, now over to you, AK Singh. What are your comments before?
I think, sir, now we need to remove the overlap and, make presentations in such a way that they are sequential and, they are getting dovetailed with each other so that, there is a kind of a team-like effort.
Good suggestion. So that it flows like a story
Yeah,
instead of
yeah.
disjointed silos.
So,
We will bring connectivity with the presentation so that the sequence also we will
relay
decide
race
upon.
type, kind of a relay race.
Good, very good. Good
I will
idea.
get it done.
Now, Neeraj, anything you have? And otherwise, Dr. Khatri, I don't see Neeraj. Dr. Khatri, anything you have?
No, sir. Rightly
Okay.
mentioned that we should look into the order of the presentations which are going to be there, and also there should not be any redundancy or overlapping in the presentation slides also.
Absolutely. So we will have again tomorrow. Let them refine it, and day after tomorrow we'll meet again. We'll let them give one day. They will look at global scenario from other space agency, what they are doing, what ISRO's priority, all that. No, in the discussion you should bring. Chinese are doing this, and European Space Agency is doing this. So we should do differently. This is what we are suggesting. So that you don't really restrict to ISRO sites. Please look at even those sites and then bring in the discussion. I have seen the publication from NASA, so and so, in which they are doing this. And so this is different from what they are doing. It's a new approach. So like that, no, you people should speak like a professional international scientist in that forum. So that means you have to do one day work. One day, today, tomorrow, totally you people work. You should bring in that field what you are presenting, a global scenario, Indian scenario, Amity, what you want to do from Amity in this, which is something different or something unique which you want to do. So when you are discussing, during the discussion, you should speak like that. So that then you have a global awareness, not just only ISRO's website. Please see all that in your domain, what they are in your domain. If it is data analytics, data science, what they are doing. If it is AI application, what all open literature available. Please do a thorough homework, thorough study on this. Now, we can move to the next one. Can we go to the last presentation, Shifali?
Dr. Rika from Chhattisgarh campus, sir. We have
Rika?
proposed her name in data analytics part, sir.
Yeah. Dr. Rika, please go ahead. Can we see you on the
Dr. Rika?
screen and share screen?
Dr. Rika?
Prasad, you can also guide them. You sit with them, call them. Shifali, you give him all
Sir.
the linkages because he knows the space relevance.
Sir.
But you also guide them for the global significance of this. Prasad, she will give you all the connectivity. You and Shivani spend time, and also Datta, if you can find time, so that the presentation gets refined.
These 2-3 people.
Yes. Shifali will coordinate with you.
We will do
So that,
no problem.
Then we see day after tomorrow, it should be professional. We will ask questions as if the ISRO scientists will be asking questions. On 8th, we will be asking questions. What is the NASA views on this? What are the NASA doing? What is Chinese Space Agency doing? So we will ask you those questions also, besides ISRO's relevance.
Tomorrow.
Photo.
Rika?
Yes, sir, Dr. Rika, she's traveling. She's facing some network issue. She has requested if she can present tomorrow, if all these team members are available. because she has
I think-
mentioned there is some problem.
But can she send the presentation? You just request her to send the presentation.
No, it doesn't
Sure,
matter. We'll find some time tomorrow. We'll take the convenience of all
Yeah.
people.
Yeah, we
No
can
problem.
listen tomorrow, sir.
No
And
problem. No problem.
Shefali,
Uh,
there
Rita,
used to be one more person now who worked on this lake.
sir. Dr. Abul Amir Khan.
Ah,
Where is he?
Sir, actually, Dr. Sharma and you suggested that presentation was not good, so we have not invited him today, sir.
okay. He has
But
not
he
been
has,
included in that.
yes, but
Please say
but
that.
he is ready with the presentation and everything, and he called me up in the
So
morning.
maybe tomorrow we'll listen to him
We will
also. If
listen
you are
to him.
calling Rita,
Okay, sir.
please call him so that we will
Yeah,
all
sure, sir.
listen.
You know what can be done? Suppose his whole content is not okay, but if some of the aspects are good, we can take and someone else can present, because it is not the individual, it is the amity's
Absolutely.
presentation.
Absolutely.
Huh.
Yes,
Shefali,
Prasad.
can I request you, Shefali?
Sir,
Shefali,
sir,
can I request you to send me the PPT of all these people?
sure,
Dr.
sir.
Abdul Adar, as
Okay, sir.
Dr. Ekatana said, I will compile that, the important points out of that, and
Sir.
it becomes a meaty presentation.
Sure, sir.
You know, I can compile a couple of points.
We will do
Because
that.
so many people may not speak.
Maybe, Prasad, if we can
That-
ask you in the first session to make some opening remarks in the first technical session, that after you have seen all this, that we can even think of making you as this first chair session. We'll take the advice and guidance from founder also. And so that you can just give a sum up of the whole, having seen all the presentations, this is what is going to be the sequence of presentations. So give the gist of
I
it
will
so
do
they
that.
know the
I
whole
will do
cross
that.
section. Even if suppose Somnathji is going to be there for 1-2 presentation, he will listen all the 3 sessions. What is it going to be discussed? And the
Also,
gist
sir,
of it, you bring it
also,
in 10
sir, in
minutes.
the astrobiology session, can we give this to the Honorable Vice Chancellor of Amity University, Mumbai? I mean, he could be the
Astrobiology, he
person
will
to
do that.
initiate the
No,
dialogue.
I'll do that. I'll do that. Because astrobiology, I'll be able to do that.
Oh.
You give me, I'll do that.
Okay.
He
Good,
is
good.
the life science man.
Right. So I want to thank each and every one of you. And this was very, very satisfying, better than what it was in the first session. But now lot more to be done. We want perfection, Six Sigma. And our presentation should be the best. They said this is Amity. So they should be amazed by listening to our presentation. They should be astonished. So to do that, how you would do that? Again, ruminate, think, plan, global scenario, Indian scenario, uniqueness of you can even bring novelty of this is unique. First time we are doing. So like that in certain areas, you should be emphasized like that. So we want to see on 8th, day after tomorrow, that same way what we have given some suggestion advice on each presentation, and read, understand global picture, Indian picture, importance of your work, how it will be relevant to ISRO, how it will benefit this research proposal will benefit ISRO. Bring all that in your presentation and discussions. I am sure we will be the winners. And founders' blessings is there. That is Brahmastra. So we have the Brahmastra with us. So absolutely, we will succeed. We will certainly we will make a great impact on ISRO. And I have no doubt, because founder has a dream that Amity should be the major R&D contributor to Indian space research. So how we will do it, this is one step. So please have that in mind. First, on the foremost of mind, we have to be the best. So that means how we have to present. Very clear on this. So please do that. My best wishes.
Excuse
Yes,
me, sir.
Shefali?
Yeah, Dr. Gagandi want to speak, sir.
Yeah.
So I have one question on which I need suggestion of all of the esteemed members present here. Should I need to increase the size or the number of problems in my presentation? Because I have other problems as well. Because of the time shortage, I just picked up the things which I thought that they will be like the cryptography and the sensor frame analysis.
Yeah, I was listening to your presentation. I have picked up 3 areas where you can
Yes, sir.
expand. One is the autonomous path planning.
Yes, sir.
Autonomous path planning is very important for ISRO, which you have capability in aggregation techniques and others. So you find out the image processing, path planning, obstacle detection. So autonomous path planning is in their response channel also. This is one
Yes,
of the
sir.
challenge which they are looking for a solution. In the response, this is one of the priority area for ISRO. Second is cryptic model, strong cryptic model is another area where you have strength. Elaborate on that. What is
Okay.
that you can do on the strong cryptic model? Third one is uncertainties, very important because ISRO there are many uncertainties because many things are not known. So how would you quantify the uncertainties and find a solution? These 3 areas.
Yes,
And
sir.
what is your strength? If you can give a focus, then you can, yours will be best. This is my suggestion.
Okay, sir. Okay. Thank you, sir.
When, sir, when you say cryptic means cryptic communication, particularly.
Yes.
Data transmission and also the secrecy of the data and also coding, encoding, all that will come under the cryptic
Dr.
models.
Prasad sahab.
Yes.
In times to come, as Gagandeep has a expertise or some strength in cryptography, if she can do that, ultimately in times to come when satellite as weapons, there at that time, this cryptic communication will become more and more important when, they are communicating some critical or strategic things.
Okay, so
So
best
we
wishes
had,
to everyone. And so we will again meet day after tomorrow, but that will be
Gagandeep, I
timed.
will talk to you.
We will actually
Sir,
time it.
Gagandeep, I
Yes,
I will check your
Shefali.
Yes, sir.
availability, sir, for Dr. Rika and Dr. Abul Amir Khan. As you
Yes.
suggested, I'll invite
Yes,
both
sir.
of them tomorrow.
Right.
Prasad sir
And
and
also
Silvamurthy sir.
the
Yes.
the 8th presentation will be timed. Each one, how many minutes
Yeah.
you take. And also your font size presentation also should be very sharp in terms of color combinations, the font size, not too many cluttering on the materials. See the presentation also, that how you present, what kind of visuals you are giving. And even you can just make a video, a small video. If you are relating to satellite, show some satellite moving. So in this, the path planning is very important. Debris, show some debris in a visual form. So that way it's interesting. Instead of just showing this, no, so you just Google, if you Google, all this is available. Bring something to make it interesting. They will say, yes, this is relevant to ISRO. So a space mission, show one space mission. When you are planning, the weather conditions are important. So there are uncertainties, thunderstorm could be there, lightning could be like that. No, how you present it is also important, not just only like a report. Make it very interesting. So again, apply your mind, color combinations, font size, and all this besides the contents is also important. All this please work out, then we will give final suggestions on it. Thank you. Shefali, you can just conclude.
Yeah, thank you so much, sir. I will humbly request Dr. A.K. Singh sir to conclude the session.
I think
Sir?
already Dr. Silvamurthy has concluded. I think as directed. I think thanks to everyone for wonderful presentation. There are certain gaps which have already been flagged by Dr. Silvamurthy, Dr. Neeraj Sharma, Dr. Prasad. I think which will be taken care by Dr. Prasad, Dr. Datta, Dr. Sunil Khatri, and we both. And I think when we meet again for the final presentation on 8th, things would have been ironed out by that time, and we would make a impactful presentation. And I think things have improved. नीरज जी, जब हम last Friday और आज में काफी चीजें straighten up हुई हैं.
हाँ, बिल्कुल.
और चीजें हो जाएंगी. और डॉक्टर शर्मा का जो एक सजेशन है कि जो कैंपस में, नोएडा कैंपस में, if we meet them, वो अच्छा रहेगा. तो उससे then what we would be able to do, एक जो presentation का जो template है, as Dr. Silvamurthy said, the font size, the color, the template, उसको भी एक कॉमन कर देंगे तो दैट वुड बी बेटर, बिकॉज इवन द प्रेजेंटेशन का जो टेक्स्ट या फॉन्ट है वो भी ऐसा होना चाहिए विच स्पीक्स स्ट्रेंथ ऑफ द एमिटी।
डॉक्टर सिंह, आई थिंक इफ आई रिमेम्बर करेक्टली, हमने लास्ट मीटिंग में ये डिस्कस किया था कि एक कॉमन टेम्पलेट सबको भेज देंगे,
वो हाँ वो टेम्पलेट कंटेंट का था, ये टेम्पलेट
ये भी चला जाएगा,
हाँ इसको कर देंगे
चले जाएंगे
कर दें, क्योंकि डॉक्टर सिल्वा मूर्ति सर की जो स्लाइडें 2004 की बनी हुई अब भी बड़ी लाइव हैं।
Right. So we should make it. We'll do that. I'm sure all of us will do it. Thank you so much.
Thank you so much.
Shivani,
Thank you so
for
much.
coordinating, Shifali.
Yeah, thank you so much, sir. Thank you. Thank you everyone for your kind. Thank you so much.
Then can I close?
Yeah, please, please.
Karo?